Yeah, we are live.
Yeah. Can you have the... So, good evening, everybody. On behalf of the Indian Academy of Diabetes, Ment Update, and Novo Nordisk, it gives me a great pleasure to this, pre-ESD, post-ADA update of what's the science which was discussed at the ADA before we go to Hamburg next week. And this is a scientific update related to diabesity, what is cutting edge in 2023. So, next slide. So today what we are going to do is I'm going to just discuss some of the key thoughts around diabesity as a theme and some of the key orations which were given at the American Diabetic Association meeting, annual meeting at San Diego. And then we have two very elegant talks from Dr. Bipin Sethi from Cyberbad or Hyderabad. He's an endocrinologist there. And he's going to talk about the advancements of emerging and existing therapies, the onwards development program. And then we are going to get Dr. Professor A.K. Singh, who is from Guwahati and Calcutta. He's going to talk on Oasis and Pioneer Plus program. And then we are going to move gears and pick up some more advances and updates on the ADA standard of care for diabetes by Dr. Uday Faitke, who's an endocrinologist from Pune. And then we have two sessions, which are Novo Nordisk sessions. One is Relate, which is going to be discussed by an endocrinologist from Chennai, Dr. Krishna Sheshadri, and he's going to talk on Relate, the oral semaglutide, recent advances in dual GLP-1 and SGLT2 inhibitor therapy, because that's going to be the cutting edge thing. And then my good friend, Dr. Vagesh Iyer, is going to talk to us on the dichotomy of insulin innovation and adaptation. He's from Bangalore. And then probably we'll try to do some panel discussion, and then I will give you some take-home messages and summary and closure notes. So let us move on to the primary German topic of some of the highlights of ADA 2023. And before I go to the awards lecture, let me talk of what was the type of scientific tenor and some of the interesting evidence base around nutrition surrounding weight regulation and appetite. Next slide. So fundamentally, there was a symposium on pathways to stop diabetes. And in pathways to stop diabetes, it's probably in the brain. And the impact of brain on the sugar, investigating the neural challenges to promote obesity and diabetes was discussed by Lisa Buter. Next slide. And fundamentally, if you look at it, when we eat food, it rapidly changes the neural activity which controls hunger. So here you can see that a fasted mouse, as soon as there is food which is given by intragastric infusion, if there's a glucose infusion, lipid infusion, or peptide infusion, if you do a photometry of the AGRP, the agouti-related protein photometry, immediately you can see an activity which comes up. So hunger is immediately, this is hunger signaling in the brain. Next slide. So when we have excessive sugar and fat or an obesogenic diet, the gut to brain communication is altered, and that leads to obesity and diabetes. So how does the gut brain axis dysregulation contribute to this? And how does fat and sugar have similar or different effects? Next slide. So as I told you, food rapidly controls the neural activity to control hunger. Next slide. And next slide. You can see that in the previous slide, please. Excessive fat and sugar intake causes distinct effects on the gut-brain axis. High sugar selectively blunts the glucose-mediated hunger neuron inhibition. And the nutrient intake does not elevate hunger effectively in obese mice. And this was, unpublished data which was presented. And clearly, if you see lean controls, high sugar diet, and if you do a glucose infusion and a lipid infusion, clearly you can see that high sugar diet selectively blunts the glucose-mediated hunger neuron inhibition. And nutrient intake does not elevate hunger effectively in obese mice. Next slide. And to monitor hunger neuron and its downstream activity during feeding and glucose metabolism in lean and obese mice at a cellular level. How do neurons fire in lean versus obese mice? Because, there is a definition of hunger neuron outputs which regulate what we eat and how glucose is modulated. And you can see here very clearly that lean versus obese, the neural pathways are different for hunger. Next slide. And it is important that if you manipulate activity of specific neurons to prevent or reverse obesity or diabetes, okay, you can actually make a difference. And some of the cutting edge molecules, like we will have a discussion on semaglutide, actually is trying to manipulate at a neural level this gut brain axis to prevent or reverse the effects on obesogenic diets. Because we all love food, we are all living in an obesogenic environment. But can we switch off these or manipulate these specific neurons, which are the hunger neuron outputs, whether it is in the arcuate nucleus or the hypothalamus or the paraventricular nucleus and so on and so forth. So can we disrupt the gut-brain axis or manipulate neurons? Next slide. So fundamentally, the project to stop diabetes is that we need to study obesity and gut-brain communication at a cellular level for cellular resolution and remission. We need to manipulate gut-brain axis and assess the prevention and reversal of obesity. We know one of the biggest limitations of current medical therapy is the weight regain. And the obesity-induced plasticity of gut-brain circuits may drive this. Because what happens is we lose weight very well. But unfortunately, there is weight regain. And it's important to recognize that one of the major limitations of the current treatment options is that the gut-brain circuit becomes plastic and resistant. And can we switch it off? Can the weight loss be persistent? And for that, it's very important to understand the molecular and the circuits which underline the underpinnings between gut-brain axis of diabetes and obesity. And they ultimately also reduce stigma. So I think when we need the moving of needle of our people living with obesity and diabetes, that's the key. And that's what Lisa talked about during the ADA meeting. Next slide. Other thing is we eat carbs. And Carol Kirkpatrick said, moderate carb eating is the best. How much carb? Because we are a carbohydrate country. I did the starch trial for India, and we showed that we eat carbs and fats. Next slide. And we keep on eating carbs and fats. And obviously, next slide. It's important to recognize that we need to describe the carbohydrate restricted diet patterns. We need to understand that carbohydrate restriction is a key to cardiometabolic risk, weight management, lipoproteins, and A1C. And we need to illustrate that if you moderate the carb dietary pattern, it is optimal for cardiometabolic health and diabetes management. Next slide. And clearly you can see if there is moderate carbohydrate restricted dietary pattern, which is 26 to 44% of calories from carbs, versus low carb diet, which is 10 to 25%, versus very low carb diet, which is less than 10%. Probably the moderation may be the key. Next slide. That's what she was trying to talk to us. And is there data of carbohydrate restricted diets versus high carb diets? Well, this is a summary slide of all the RCTs. There are 12 RCTs, 3 months, 9 RCTs, 6 months, 3 RCTs, 12 months, 3 RCTs, 12 months, 24 months. So if you see head-to-head data of RCTs, you can clearly see the short-term studies less than 6 months. There's a greatest weight loss in carb-restricted diets. But in the long term, the weight loss benefits come down appreciably or are negligible. Next slide. So obviously, the conclusion Carol concluded is moderate carbohydrate eating is the best. Next slide. And you can see that the persistence of that, because it is difficult to maintain severe restriction. And therefore, moderate intake might facilitate long-term adherence. Next slide. It can also impact lipids. Next slide. We know that when we restrict too much of carbs, the lipid profile goes up and you get saturated fat, which is going up. And clearly we see there is a dose-dependent effect of carb restriction on LDL levels. Next slide. And this is a data which clearly shows that moderate carb eating is the best. Whether it is impact on LDL cholesterol or on triglyceride levels. Low carb versus very low carb, you can clearly see that in the low carb or very low carb, triglycerides consistently come down. But low carb versus very low carbs, on the LDL level, there is an increase. But in the low carb diet, the LDL increase is not as robust. Next slide. So this is the big thing. So clearly we can see that the A1C reduces at 12 months with 40% of carbohydrate 0.15%, 30% of carbohydrate 0.2, and 15% of carb 0.4. So when we restrict carb, the A1C comes down. But restricting carb is difficult to maintain, especially severe restriction. And moderate carb intake might facilitate long-term adherence. That's the theme. Next slide. There is data published in RCTs now from the Predimed trial and the CardioPrev trial, clearly showing in atherosclerotic prevention. When you do the macronutrient composition of carbs around 40%, you can see some outcomes which are illustrated in this slide very clearly. Moderate the carb is the theme. Next slide. Extremes of carbohydrate intake increases mortality. So if you have very low carb, the pooled hazard ratio for mortality is 1.1. And if you have very high carbs, more than 70%, again, the pooled hazard ratio is 1.3. So moderate the carbs. Too much is bad, too less is bad. And therefore, the take-home message was carbohydrate-restricted dietary patterns, lower triglyceride and A1C, are better than very low carbs, easier to maintain, and are much more healthy with proteins and unsaturated fats. And of course, there's some data of Mediterranean diets, one of the best. Next slide. So how should we curb carbs? William Yancey said that very low carb eating is the best. Next slide. So should we curb, previous slide, should we curb the carbs? Are the very low carbohydrate eating the best? Next slide. Clearly, there's a case for low carb eating, and there's a case for low carb eating not increasing the cardiovascular risk. Next slide. So Dr. Jocelyn said in 1923, before insulin discovery, the diet was the core. And if the food of carbohydrates are of no use to the body and must be removed by the kidneys, entailing polydipsia, polyuria, pleuritis, and renal disease. Next slide. And the Jocelyn diet of 1923 had only 40% of calories from carbs, 15 grams. Proteins was 17%. Fat was, 75%. And this strict diet of meat, poultry, game, fish, clear soup, gelatin, eggs, butter, olive oil, and coffee and tea was a diet which was given then. Next slide. And you could see the data that you can see the A1C came down. Next slide. The glucose insulin levels get better. And that gave to this Ludwig model of carbohydrate insulin model. Dietary carb or starch or sugar raises glucose and insulin. When we restrict the carbs, it reduces the diet contribution of serum glucose and then lowers the insulin levels. We know insulin is a very potent stimulator of lipogenesis or fat storage and is a potent inhibitor of fat burning or lipolysis. Lowering the insulin level or dose leads to burning of the stored body fat, raising the ketones and lowering the body weight, giving birth to the keto hypothesis. Next slide. So this is a typical glucose insulin response to a meal. Next slide. Clearly, you can see the 13 trials which met the criteria of carbs less than 45% with 2 to 26% duration showed a delta of A1C drop as the carb became less. Next slide. And you can see if there's a network meta-analysis of diet effects on glycemia, 56 trials, 5,000 participants, 9 diets of different types, low fat, Paleolithic, low glycemic load, controlled diet, low carb, moderate carb, high protein. Proportion of the nodes is different. The thickness of the lines is proportional to the number of studies, each with direct comparison. Next slide. So clearly this meta-analysis showed that A1C reduction with low carbohydrate diet was ranked best dietary approach, 84% Sukra, Mediterranean 80, and Paleolithic 76%. Next slide. So obviously that was the case that low carb eating does improve glucose, but may not increase cardiovascular risk or lower cardiovascular risk. Next slide. So when it comes to the saturated fat and CVD, we clearly know that outcomes are very well established long time back. Next slide. And clearly we know that the very low carb diet, the LCD, versus the low fat diet, the small LDL and total saturated fats in the orange, the lower saturated fat at a lower dietary intake was 3 times higher. Next slide. So clearly we recognize this. And clearly you can see whether this is a patient with diabetes, dyslipidemia, hypertension. You can discontinue some of the medications and you can adopt a remission process. Next slide. So low carb intake rapidly reduces glucose and insulin levels, dose dependent. Lower carbohydrate intake lowers the carbohydrate blood glucose trends, lowers the medication requirements, blood pressure decreases, lipids decrease, and typically the LDL doesn't increase and small dense LDL decreases. Next slide. So let us now look at the seminal lectures. The Edward Bremen Lecture Award was looking at lowering of liver fat in pre-diabetes and diabetes. Because we know in remission, direct data from Roy Taylor showed us that if you reduce fat in the liver, fat in the pancreas, you can remit diabetes. Next slide. This lecture was delivered by Elizabeth Parks. She's a professor of nutrition and exercise physiology from University of Missouri. And Liz delivered this lecture. And Dr. Bierman was known for his work on physiological and nutrition regulation of lipid metabolism, the nature of lipid and lipoprotein disorders. He was a pioneer of human cultured cells for atherosclerosis study and edited the atherosclerosis journal. Next slide. So fundamentally, the liver fat, and we know that now this liver fat is called metabolic associated fatty liver or MAFLD. And there is an effect of liver fat on hepatic disease. So if you restrict energy, then we clearly know that there is a role of nutrient excess and DNL on fat accumulation. And there is a reroute hypothesis. So if you reroute the substrates or rotate or reroute the substrates away from the liver, to remove the excess nutrient toxicity load with restriction of energy and exercise, you can cause remission of disease. So clearly we recognize that when there is nutrient excess and de novo lipogenesis on fat accumulation, you need to reroute the substrates away from the liver. Take away the excess nutrient toxicity load, restrict energy, and do exercise. Next slide. So clearly, when we look at the model of the de novo lipolysis or lipogenesis physiology, we can see at each level of liver disease severity, the hepatic de novo lipogenesis increase in MFLD due to increased gene expression of fatty acid synthesis. Though the contribution of dietary fat and plasma-free fatty acid is not significantly altered. So clearly we can see that there is a change which is happening in the biological underpinnings, is what Liz was telling us. Next slide. So typically an African-American woman, 47-year-old, body weight 80 kilogram, liver fat, SGOT, SGPT elevated, NAFLD score of 6, triglycerides of 103, insulin resistance with a DI of 678. And if it is given dietary treatment, you can see loss of weight, 72.9. The liver fat comes down to 7%. The liver enzymes come down to normal. The MFLD or NFLD score comes down. Triglyceride comes down. Insulin resistance sensitivity improves. Clearly, you can see biological changes. Okay, next slide. So clearly, when there is de novo lipogenesis increased with high liver fat versus low liver fat, you can see a switch happening. You can see the magenta as de novo lipogenesis. You can see the blue as free fatty acids, and you can see the dietary fat, and you can see the switching happening. Next slide. So the reroute hypothesis clearly showed that offload the nutrients, modulate the insulin resistance and hepatic mitochondrial dysfunction, and exercise and cause remission of the disease. And when they did the study, they did liver biopsy, they did standard of care, they restricted energy with high intensity interval training. And then they looked at visits by dietitian and exercise physiologists. They did DEXA, MRI, and MRS. And then they again did a liver biopsy as well. Next slide. And they actually studied all this. And clearly, if you see standard care versus treatment on liver histology, there was significant improvement on NAFLD score, on fibrosis, on steatosis, on lobular inflammation, and hepatocellular bulimia. So there is a tissue resolution of the hepatic steatosis. Next slide. So elevating or offloading the nutrient overload with diet and exercise. When you restrict sugars or energy, improve physical activity and lose weight, improve fitness and decrease the nutrient overload, the TR factors that control lipogenesis are downregulated. The substrate which make fatty acid like fructose and glucose are downregulated. They reduce liver fat and cell death in NASH. They lower the hepatic glucose diarrhea and glucose production. And there's remission of NASH, pre-diabetes, and type 2 diabetes. This is the physiology. This is the pathology. And these are the pathways which are involved in the same. Next slide. So clearly in this lecture or the oration, we clearly studied that the NASH's metabolic environment of the liver is unique, and there is a significant increase of de novo lipogenesis. These are seen across all diverse ethnic groups, different ages, as well as both the genders. Higher levels of liver disease have a greatest impact on the de novo lipogenesis and expression of FAST. And therefore, this data will be used better how the fat or adipose tissue, muscle tissue, liver tissue coordinates with improvement of insulin function and liver health. And this is a key insight which Liz Parks demonstrated. Next slide. The biggest award lecture at ADA is the Banting Medal. And this was based on a pioneer who probably might get a Nobel Prize on the multi-receptor drugs, single agent, dual agent, triple agent, on overcoming obesity and diabetes. Next slide. This was delivered by Matthias Schopp. You know that Professor Banting got the Nobel Prize for discovering insulin. And Professor Matthias Schopp is from the German Diabetes Research, and he's at Nuremberg and München. And clearly, he was the discoverer and pioneer on various cutting-edge drugs, including what we are going to learn today about a new drug like liraglutide to semaglutide, and how semaglutide is available both in the oral space as well as in the injectable space. And then, of course, the single agents are not sufficient. There are dual agents and there are triple agents which are coming up. And all these three have some cutting-edge data which was discussed at the Science in San Diego and will be discussed soon at the EASD in Hamburg. Next slide. So clearly we know that there are therapies which promote weight loss, which are looking at caloric deficit through lifestyle, through pharmacology, and through surgery. And when there is caloric deficit, how does biology respond to it? There is subjective perception of fullness. There's increased hunger and desire to eat. There's a decreased level of satiety hormones and increase of hunger hormone, and there's decreased energy. So there is a perpetual cycle of weight loss and weight regain, which is emotionally, physically, and economically challenging. And therefore, every time you lose weight, it comes back with a rebound, and it leads to more challenges, economically, physically, emotionally, and a lot of complications. And obesity is a disease now. Next slide. Clearly, the existing weight loss interventions in the lifestyle space are disappointing. Very low calorie diet or intermittent fasting, they all cause weight losses in the percentage of 6 to 4%, 6 to 10%, 3 to 5%. Clearly, we recognize that the anti-obesity medicines can make you lose weight up to 3 to 17%. And the gastric banding, sleeves, and bypass can go up to 25 to 30%. But can we move this gear up to 25%? That's also not looking impossible. Next slide. So there are single receptor agents which modulate the glucagon receptor signaling. So glucagon receptor signaling pathways are GLP-1 like agents. And we know there are dual receptors which will impact glucagon receptor signaling and GLP-1 receptors. And there are triple receptor agents which will improve signaling of GIP receptor, GLP-1 receptor, and glucagon receptors. So in 2006, there was a single receptor. In 2009, there was dual receptors. And in 2015, there were triple receptors. You can have GIP receptors or GLP, GIP receptors. So there is an evolution of gut hormone receptor agonists for management of obesity and diabetes. Next slide. So let us look at our first audience quiz. Identify the two statements with regards to the actions of triagonist. 1. A. GLP-1 decreases appetite. B. GIP-1 potentiates insulin response to meal. C. Glucagon decreases energy expenditure. D. GLP-1 increases beta cell function. Next slide. So if you look at the proposed actions of triple agents, the GLP-1 improves insulin sensitivity and GIP-1 mediates weight-independent insulin sensitization. At a weight loss effect, GLP-1 decreases food intake and switches off appetite. Glucagon increases the energy expenditure, so you are burning your energy due to glucagon. You are switching off your appetite due to GLP-1, and GIP-1 modulates the GLP-1 induced weight loss and nausea. So if you do all the three together, that's how they work. At a beta cellular level, the GLP-1 corrects that first phase of insulin secretion and improves beta cell function, while GIP will potentiate insulin secretion in response to need. At the adipose tissue metabolism level, the GIP-1 will enhance free fatty acid and glucose uptake, while GIP also improves metabolic flexibility and lipid partitioning. And at a cardiovascular level, GLP-1 improves the lipoproteins and biomarkers of vascular inflammation. Next slide. So clearly you can see that GLP-1 decreases appetite. Clearly there. GIP-1 potentials insulin response to meal. Glucagon increases energy expenditure, does not decrease it. And GLP-1 improves beta cell function. So glucagon is the key. It increases the energy expenditure by two pathways. One is the liver futile cycles, which means these are two metabolic pathways which simultaneously run in opposite direction. And they have no overall effect in either way to dissipate energy from heat. And glucagon also augments the energy wasting activity of the UCP1, which is uncoupling protein 1, of the browning adipose tissue and white adipose tissue. So fundamentally, glucagon makes our cells more efficient and improves the thermoenergetics of the cells and whole body energy expenditure. Next slide. So if you look at rodent data, which is Dr. Chishop's work, the preclinical efficacy, the triagonists decrease the body weight the most, and the triagonists and the dual agonists cause similar reduction in food intake. So when you look at body weight reduction, if you use a triple agent, 25% like bariatric surgery, dual agent maybe 15%, and single agent maybe 10%. But the dual or triple agent cause the same food intake reduction. Next slide. When we look at fat mass, the triagonists decrease the fat mass the most compared to a dual agent or a single agent. And triagonists also decrease the plasma cholesterol the most. Next slide. And clearly also we saw, if we look at triagonists and dual agonists, the glucose level reduction was similar and the insulin level decreased was the most, and again very similar. Next slide. So clearly you can see that if you are able to put all the three in one, GLP-1, GIP, and GCG, single peptide receptor agonists like retatrutide, which is now available for approval now, it's not yet approved. You can see the A1C will come down over a period of time. Next slide. So clearly we know that single, dual, and triple agents are safe for therapy. Their benefits are at par with probably gastric bypass. And they are clearly standard of care. Next slide. So I think what I have done is given you a glimpse of where treatment and cutting edge is going, where the science was delivered at the ADA. And the ADA science has clearly evolved that the GLP-1 receptor agents, single, dual, or triple, are here to stay. Their weight loss impact is compelling. Whether you give it the oral GLP-1 or the injectable, the data is similar and the data is robust. And beyond just weight loss, they also have some very good cardiometabolic impact. Thank you so much for a patient hearing. And I'm sure when we come back for the panel, if there are questions, I'll be more than happy to answer. Thank you.
Thank you, sir. Thank you for your wonderful session on bringing out the interesting topics discussed from the ADA sessions and also taking us through a flow starting from the importance of diet and sugar, higher sugar intake, how it impacts with the obesity and glycemic control, as well as the gut brain axis involved in that. With from there to processing to how curbing the carbs would help us, and also the moderate carb curve will help us in achieving the long term maintenance as well, with the recent updates of newer molecules like single, dual, and triple agonist, and their role in weight and glycemic control as well. Thank you so much for your wonderful session, sir. Now we would like to move on to our next session, that is the exciting advancements from emerging and existing therapies. For us, to take us through that, we would like to invite Dr. Bipin Sethi, sir. He is an endocrinologist from Care Hospital, Hyderabad. He has a rich clinical experience of more than 35 years, and he's been a lifetime membership and faculty of various scientific organizations, including the Endocrine Society, RSSDI, and APA. He has publications in various national and international journals, as well as been associated with very important clinical trials. And he has an extensive teaching experience as a former professor of endocrinology across very important medical colleges of India. So, with this, I would like to invite Dr. Bipin Sethi, sir, for giving us a lecture on Onwards Development Program. Over to you, sir.
Thank you. Thank you, Sumati. Are you going to show the slides, or shall I share my slides?
Yes, sir. It will be displayed from our side as well, sir. If that's
Okay,
convenient for you, we
so
can
go
proceed.
ahead.
Yes.
Thank you very much. After a very exciting and insightful talk by Dr. Shank on the GLP-1 and GIP based therapies, we are now talking about basal insulin, which is the ICODEC and the Onwards Development Program. Can you show the next slide, please? There were many studies that were done with this molecule, and we will be concentrating on the Onwards 1, Onwards 3, and Onwards 5, which were done in patients who were type 2 diabetics and who were never been exposed to insulin in the past. And the comparators were the first generation insulin in Onwards 1, second generation insulin in Onwards 2, and in third study, there were basically the app-based titration versus standard basal insulin. Can you have the next slide, please? So in the Onwards 1 trial, what was done was type 2 diabetic patients were randomized to receive either ICODEC, which is a once-a-week basal insulin, comparing with glargine U100, and there were many parameters that were studied. Primarily, efficacy data was to look at HbA1c, but one also tried to look at the fasting plasma glucose, the hypoglycemias, and also the time in range. The next slide, please. Next one, please. So the treatment algorithm was very simple. The whole idea here was to see if a once-a-day basal insulin can be replaced by once-a-week injection. And after dosing, people were titrating their insulin based on the fasting plasma glucose. If the fasting plasma glucose was between 80 to 130, there was no change in the dosage of ICODEC. But if it was more than 130, one was increasing the dose by 20 units. And if it was less than 80, then there was a decrease by 20 units. Basal insulins, which would translate into 20/7, the increments were +3 or -3 or no change, and this was the change for the glargine. So the baseline characteristics of these individuals, next slide please, were essentially same. This was in terms of the age, the duration of diabetes, the baseline HbA1c, fasting plasma glucose, body weight, etc. They were equally matched between the ICODEC and the glargine group. So there was no difference in the baseline characteristics of these individuals in terms of their anthropometric data and also their lab values. Next slide, please. In terms of the therapies they were receiving, also they were equally matched. Of course, as is expected, most people were receiving metformin, followed by DP4 inhibitors, sulfonylureas. Some people were receiving GLP-1 agonists. There were smaller numbers who were receiving glitazones, alpha-glucosidase inhibitors, and granites as well. But this was also equally balanced between these two study groups. So there was no difference as far as the baseline characteristics were concerned, and also in terms of the therapy that these people were receiving. Next slide, please. If you look at the HbA1c over time, what you find is that there is a gradual decline in the HbA1c values as is expected with both but this was better reduced with icodec compared to the U100 glargine. Next slide, please. And this was at 1 year. And if you look at the time in range, which all of you know, is in terms of the values that are there between the normal range as defined by 70 to 180, and then time above range defined as values above 180 to 250, level 1 hyperglycemia, and more than 250, level 2 hyperglycemia, and you have level 1 hypoglycemia between 55 to 70 and level 2 hypoglycemia below 55. You find that while in the hypoglycemia ranges there were no differences, the essential difference between these two in terms of better time in range was because the icodec shaved off more time from time above range compared to insulin glargine, and this was significant. Next slide, please. If you are looking now at the HbA1c change from baseline to week 52 and week 78, you find that again, there is a significant reduction in the HbA1c, which is better and superior for the icodec compared to the insulin glargine U100. Next slide, please. The CGM parameters between week 48 and 52 and 78 to 74 to 78, you find that there is a significant difference in favor of icodec compared to glargine during this time, whether you look at week 48 to 52 or week 74 to 78. Next slide, please. Fasting plasma glucose levels were essentially same. Then this is very, very important, that there was no difference in the fasting plasma glucose, but because of a flatter profile, this could achieve a better HbA1c and a better time in range. Next slide, please. At week 78, it was also essentially the same. Next slide, please. Mean fasting self-monitored glucose over time also was definitely reduced from a baseline, and there were no difference between the two treatment arms. Next slide, please. If you are looking at participants who are achieving HbA1c target at 1 year and at 1.5 years, you find that in the main phase of the study, definitely more number of people achieved the target for icodec compared to glargine 100. And same was the case if you combine the main and extension phase. It was numerically better, but the number just fell short of significance. Next slide, please. Overall hypoglycemias in these individuals were essentially the same, and there was no difference between the hypoglycemias over the main phase of the trial. Next slide, please. Overall hypoglycemia over main plus extension phase, there was a slight increase in severe hypoglycemia in the arm that was icodec, and most of these hypoglycemias were accounted for by 2 subjects who had 140 hypoglycemic episodes. Next slide, please. If you look at the composite endpoint, which everybody is fond of and looking at for all therapies, including basal insulin, achievement of HbA1c target below 7% without significant or severe hypoglycemia, you find that that was achieved in the main phase as well as the main and extension phase of the study, more likely with icodec compared to the insulin glargine. Next slide, please. The weekly dose of insulin over time obviously would increase steeply over the titration phase of 12 weeks. Thereafter, there is a plateau and stability. And if you convert this for per day dosage, there is hardly any difference between icodec versus glargine. Obviously, glargine doses is going to be 7 times less than that of icodec, but per day dose, if you divide it by 7 for icodec, is essentially the same as that for insulin glargine. Next slide, please. Weight changes in this numerically, there was greater weight gain in icodec compared to that of glargine, both in the main phase and main in the extension phase, but this was not statistically significant. Next slide, please. So in summary, in this trial, when you have used basal insulin glargine compared to icodec, which is once a week insulin, you have reduced number of injections instead of 3,765, you are going to give just 52 or 53 injections. You have significant reduction in HbA1c from 8.5 to 6.9 after 52 weeks. This is sustained and maintained at 78 weeks. Statistically significantly more participants achieved HbA1c target below 9 at 52 weeks. And also the time in range was also statistically significant and better in individuals who were using icodec compared to insulin glargine. Next slide, please. So what we can conclude from this trial, that you can get better control by giving lesser number of injections per week with this newer insulin. There is no difference in the overall rates of combined and clinically significant hypoglycemias. When you are including the extension phase, overall observed rates of combined clinically significant hypoglycemias remains less than 1 event per patient year for both the arms, with a significant difference in favor of glargine, because, as I said, 2 subjects in this trial accounted for 105 hypoglycemias in the icodec arm. Had these subjects not been there in this arm, this difference would not have been there. This was probably in the titration phase itself, and subsequently this was not seen. Statistically significant, more participant adherence was likely, and the chances of getting HbA1c without weight gain for hypoglycemia are also more with icodec. So this is what we conclude from the comparison with what is a gold standard, or we can say the bashing boy for most insulin comparison studies. Next slide, please. In this study, which was essentially similar but multinational, including patients from China, what was done was icodec, which is now a 3rd generation basal insulin, was compared with a 2nd generation basal insulin, which is degludec. The inclusion criteria are essentially the same, but these subjects were insulin naive, just like in Onwards 1, and they had not received any insulin in the past. Next slide, please. Now coming to the results directly, you find that in this trial, there is non-inferiority, which is the first part of any study when you compare with a standard molecule, but also there is superiority of HbA1c from baseline to week 26 with insulin icodec compared to insulin glargine. Next slide, please. The treatment algorithm was essentially same. Increase the dose if the level is more than 130, decrease the dose if the level is 80, and maintain the dose if the levels are between 80 to 130. Of course, the titrations were about approximately 3 units per titration, and this would translate into about 20 units for icodec. Next slide, please. Baseline characteristics, again, like all studies which are done in randomized controlled manner through the IVRS, you find no difference in the baseline characteristics in terms of duration of diabetes, HbA1c, fasting plasma glucose, body mass index, body weight, etc. Next slide, please. Or the baseline therapies, which again would definitely include the drugs like metformin, sulfonylurea, and the spread was equally there in both these studies. Next slide, please. Both the groups. Again, the mean HbA1c from baseline to week 26 was better with icodec compared to the insulin. The icodec produced better reduction in HbA1c compared to degludec, and this was definitely statistically significant. Next slide, please. Mean fasting plasma glucose again came down smartly. Initially, of course, it would be much more steeper reduction because the titration phase is about 3 months. Thereafter also, but they were similar in both these groups. Next slide, please. The fasting plasma glucose, which was measured in the laboratory, also was essentially the same in both the groups. Next slide, please. Participants achieving HbA1c targets at week 26, this was just a 6-month trial, were again more likely to reach the targets if they were on icodec compared to if they were on degludec. And if you look at the composite endpoint of people having no hypoglycemia during the preceding period, then also the likelihood of this being achieved with the degludec was lesser than that with the trial drug, that is icodec. Next slide, please. Overall hypoglycemia rates were essentially same between these two studies, unlike in the onwards one. Next slide, please. And weekly insulin dosage over time, of course, increased more steeply in the first 12 weeks and somewhat thereafter. But if you translate again into the daily dosages, icodec divided by 7, you find that there is no difference in the dose per day. Next slide, please. Weight change was again numerically slightly more with icodec compared to degludec. Next slide, please. So in conclusion, this shorter study with a second generation insulin analog compared to icodec showed essentially superior HbA1c reduction with icodec and better reductions even without having hypoglycemia, numerically higher weight gain in individuals who were receiving icodec, but without having an experience of excess hypoglycemia. And naturally, number of inductions were definitely improved. So this is important study wherein the first generation insulin has been compared, the second generation insulin has also been compared. This is a shorter study. It does not include time in range, but does show the superiority of this longer acting basal insulin. Next slide, please. I think this I have covered. Next slide, please. So in the onwards 5, this study was basically again having similar characteristics wherein you used icodec along with once daily basal insulin analogs. The difference here was that the titration was done by an app. And this was this is some kind of situation which the patient is empowered and has access to titration by an app, and he or she can then do this by themselves. And this study is unique and important in that aspect. We know that insulin glargine also has been in the past titrated by app. So what would there be a difference if you use basal insulin versus this insulin, which is otherwise superior with an app? Next slide, please. Again, the HbA1c reduction with this insulin is better than that of the standard basal insulin analogs at week 52. Next slide, please. A number of people who achieve targets is also again better with this insulin. These are almost replicating whatever else happened with the other first generation insulins. Here, the titration was based on the app, and there is a separate thereafter. Next slide, please. Overall hypoglycemias were also same in both these groups, whether they titrated by app or they titrated in the standard way. Next slide, please. And mean weekly dose. Now, this is very important. There have been some studies in the past wherein patient empowerment versus physician-based titrations have been compared, and there have been shown in the Atlas study that the physician-based titration produced slightly inferior result compared to patient-based titration because patient can then self-titrate. The same thing happened with the app-based study. That icodec, which otherwise was superior insulin, did produce a better target achievement because these people titrated better. Next slide, please. And the body weight change was slightly more in the favor of icodec producing more weight gain, but this is not very, very significant. Next slide, please. The patient satisfaction questionnaire, there were two wherein they were questioned about convenience, flexibility, satisfaction, and willingness to take the recommended treatment. This was more with the app-based treatment and icodec compared to the other insulin. Next slide, please. The compliance domain also was marginally better, and it reached significance with the icodec compared to the other basal analogs. Next slide, please. And so in summary, what can we then confer from this study? In insulin-naive adults, in the real-world setting, when once a week icodec is compared with doses guide app versus once daily basal insulin analogs, it shows superiority in HbA1c reduction, significant improvement in the treatment satisfaction and compliance, And titration was obviously higher with the app-based, resulting in an improved glycemic control in the iProdac arm. Next slide, please. So we can now conclude that changing the injections to once a week from once daily, be it from glargine, be it from iProdac, does produce a significant, meaningful reductions in HbA1c without the risk of hypoglycemia. If we take away those two patients which contributed to 102 hypoglycemias in onwards one, and if you are empowering the patient with an app-based therapy, you are likely to get better reduction, largely because you're using a higher dosage. Thank you very much for your patience here.
Thank you, sir. That was a wonderful summary of the Onwards trial program. And we are also intrigued to know that there is a once weekly insulin molecule icodec, which is coming up with better efficacy and also with lesser injections. More importantly, with no increased risk of hypoglycemia. So this gives us hope towards the uh, future updates and future management in the type 2 diabetes as well as type 1 diabetes. Sir. So I would also like to bring out the few questions from the audience side. So as you would not be available for the panel discussion. So historically, the adoption of innovation takes time, but with the number of injections coming down with these molecules from 7 to 1, so do you see a change in this trend, sir? That would this molecule be adopted more easily and more faster compared to the historical events?
Well, there are two issues there. One is the issue of definitely convenience, taking an injection once a week versus once daily. A second issue is that of the cost. If you look at the GLP-1 based therapies, essentially people would prefer once a week injection, but all the patients who were taking once a day injection, which was liraglutide, did not automatically shift to once a week dulaglutide. So I guess there are other factors which might also has to be looked into. But given the treatment satisfaction, adherence, preference, it is quite likely that if the cost is not hugely different, people might take this up. And there's small correction there. The type 1 study did not show the kind of result that type 2 studies did. We have not discussed that. So it is more likely that it will be adopted by a larger cohort of type 2 diabetic patients because you have, as you rightly said, achievement of targets without hypoglycemia, and that's very great.
Thank you, sir. Thank you. So next, do you think this reduction of injections will ensure insulins are considered early in patient treatment?
I think we are moving into a arena, as Dr. Joshi said, wherein we are having therapies other than hypoglycemia control, just hyperglycemia management. So there is going to be a tough tussle between the bimixes and trimixes versus once a week insulins. And given the weight reduction, I think if the baseline weight of an individual is more, the likelihood that the patient would tilt towards the bimixes or trimixes is more compared to basal insulin. But if basal insulin are to be chosen, then the likelihood that they would choose a once a week therapy is very great.
Thank you, sir. Sir, and one more question from audience. This is, can we use this once weekly insulin in type 1 diabetes?
I said there was a study that was conducted in type 1 diabetics, and the results of that was published, and they showed that there was no great improvement with iProdac. And they said that probably type 1 population is quite different from type 2, which all of us know, because they also have a component of prandial dose adjustment. And the results with iProdac in that particular study compared to the basal insulin of other type, which was given once daily in Degludec, were not showing superior results. So in type 1, it appeared that this program is not going to progress forward. Though we were also very excited that it should happen in those children who already are taking 3 prandials, but unfortunately, in that particular study, it did not happen.
So thank you. Thank you for this update, sir. And with the world moving towards once weekly insulins, Have you experienced the best of OD insulins already, sir?
I think so. The movement from NPH to glargine to detamere to Icodec to glargine 300 was a significant movement. And now, with once a week, I think the dream of basal insulin is going to be realized. It might be pointed out to the audience and also to everyone. Basal insulins were not the first insulins. We had only a short-acting insulins. Innovations were more for basal insulin. Imagine mixing fish sperms with insulin to prolong its action, and thereafter attaching the fatty acid or cell group or making it precipitated bodies pH. So more innovations in basal insulin. The first generation insulin, namely glargine 100, firmly established the role of a peakless, flattened 24-hour acting insulin, and we are moving forward in that direction. And this is really a good development. If there are insulins which act once in a month, obviously one would like that. But so far, the progress has been very significant, and that's very great.
Thank you, sir. Thank you for your wonderful explanation to our questions as well, sir.
Thank you very much for adjusting me, and thank you very much. I have to leave now. Have a great day.
Thank you, Bipin. Thank you so much.
Thanks, Shashank.
So, moving on to our next session. So, our next session under the topic of recent emerging and existing therapies, I would like to invite our next speaker, Dr. Avdesh Kumar Singh. He is a senior and consultant endocrinologist from GD Hospitals, Diabetes Institute, Kolkata. He is the editor of Williams Textbook of Endocrinology, South Asian Edition, and he is an executive editor in Clinical Keys, Indian Point of Care in Diabetes and Endocrinology, and he's an associate editor in the World Journal of Diabetes, International Journal of Diabetes in Developing Countries, IGDDC, and he's an H index author in more than 35 publications, and he has won VG Nadugowda Oration from National RSSDA, Chennai 2022, and also Birsa Munda Oration, Jharkhand RSSDA. And he's the most inspiring diabetologist and endocrinologist of India. He's been awarded by this award by ex-president Sri Pranab Mukherjee on the year 2020, and he has also received the Young Achiever Award with gold medal from NUCD Bhubaneswar. And he has had more than 125 publications and more than 32 meta-analyses among them in the international and national journals. With this, I would like to hand over the session to Dr. Avdish Kumar Singh, sir, to brief us on Pioneer Plus and Oasis data. Over to you, sir. Next slide, please.
So I will present my own slide. So can you allow me to share my slides, please?
Sure, sir.
Anirudh, can you allow Dr. Avdesh Kumar Singh to present the slides?
He can present.
Yeah. Thank you.
Thank you, organizer. So this is a Novomed slide, which I have made and edited according to my flow of presentation. So thank you, Dr. Joshi, and thank you for inviting me to present something what happened at ADA concluded recently. My honor to be sharing that with the star-studded speaker. So let me start with two of the trial. I thought to put Pioneer Plus before Oasis because many of you might not be knowing why the semaglutide, oral semaglutide, started with the higher strength of doses. Remember, oral semaglutide in the conventional anti-diabetic dose was 3, 7, 14 milligram. Scientists realized that this is not only an anti-diabetes drug, but this drug has a potential to reduce body weight. And if you look at the Pioneer trials, 10 Pioneer trials done with oral semaglutide, 14 milligram. The 14 milligram, showed highest weight reduction potential compared with their own GLP-1 receptor colleagues, including injectable liraglutide every day and injectable dulaglutide once weekly. So perhaps this, might be the research focus for Novo Nordisk to go for a higher strength of oral semaglutide and to look whether these drugs might be working as an anti-obesity drug. So that's the, preamble to why these Pioneer Plus and Oasis trial was started. So the Pioneer Plus trial was actually done to look at the higher strength of oral semaglutide 25 and 50 milligram in people with type 2 diabetes. So let's start with the trial design to tell you that this is a double-blinded randomized controlled trial that compared three things. First, they went to, titrated from 3 to 7 to 14 to 25 and 50 milligram and continued on this, the highest dose of 50 milligram oral semaglutide in one arm. The second arm was, they continued on 25 milligram. They didn't go further to 50 milligram. And the third arm was the approved oral semaglutide in people with type 2 diabetes, that was 3, 7, and 14 milligram. So as you can see, this is a head-to-head trial of 14, 25, and 50 milligram of oral semaglutide. The primary outcome of this study was to look at it's a diabetes trial. So of course, the primary outcome was to look at the HbA1c changes at 52 weeks, so pretty long 1-year trial. And the secondary outcome was to look for the body weight, because the entire intention was to look whether the higher strength of oral semaglutide 25 and 50 has got any additional merit in terms of weight reduction. And of course, the safety outcome of paramount importance, whether increasing the dose from 14 to 25 and 50 has got any additional safety signals. So the classical way of conducting this trial are the people with type 2 diabetes with HbA1c of 8 to 10.5, receiving 1 to 3 oral glucose lowering drug, failing to achieve HbA1c target, and they were overweight, as you can see, BMI more than 25. So that was, and with some classical exclusion criteria. So if you look at the baseline characteristics of this trial in the 3-arm 14, 25, and 50 milligram, they're fairly matched. You can see with a mean age of 58 years, with people having a duration of diabetes somewhere between 9 to 10 years, HbA1c hovering around 9%. And if you look at the body weight, because this trial was conducted in people with BMI of more than 25, so they are not typically obese more than 30 like a classical anti-obesity drug trial, or more than 27 with one risk factor. So these are type 2 diabetes trial with overweight population. So their mean body weight was hovering around 96 to 97 kg. They are equally matched other hyperglycemic drugs, including metformin, SUs, SGLT2, and DPP4, as you can see. Of course, I believe that those who were on DPP4 were at the baseline were stopped while adding oral semaglutide. Now, if you look at the primary outcome, as you can see on your left-hand side, you can see there is a significant dose-dependent HbA1c lowering with the higher strength of oral semaglutide. And as you expect, the higher the dose in 50 milligram, there was a highest HbA1c reduction of nearly 2.2%. Compared to, if you look at the oral semaglutide 14 milligram, the classical approved dose, minus 1.5. This speaks volume about what we learned in the Pioneer trial, across 10 Pioneer trial, that average HbA1c reduction with oral semaglutide 14 milligram, that is Rybelsus, is between 1 to 1.5%. This was again replicated in this double-blind randomized controlled trial, comparing with the higher strength. So you can see nearly 0.5% additional HbA1c loss with the higher strength of oral semaglutide 25 and 50 milligram, which was highly statistically significant. Now, if you look at the body weight loss here, that was the main clue, although this was the secondary outcome, but the entire intention was to look at whether increasing the dose of oral semaglutide from 14 milligram to 50 milligram, can you achieve additional weight loss? So 2 lessons learned from this, Pioneer Plus trial. First, if you look at the people who lost more than 5%, it was, of course, was there with the 25 and 50 milligram. But as you can see, even 14 milligram of oral semaglutide, nearly everyone lost 5% of body weight from the baseline. You look at this left-hand side graph. Now, if you look at the absolute body weight reduction, comparing 14 milligram to 50 milligram, nearly twice. So as you all know, across the Pioneer 10 trials or 8 multinational Pioneer 1 to 8 trial, the average weight loss was around 5 kg. This was again replicated in the Pioneer Plus with the 14 milligram. But what was interesting to note, with the increasing dose, there was a dose-dependent body weight reduction as well. So here you have got a drug that would produce additional HbA1c lowering along with the weight loss. And that is very interesting in the Pioneer Plus trial. So at 50 milligram, you could see almost twice body weight loss from 4.5 to 9 kg plus weight loss with 50 milligram. And this is huge in terms of weight loss with the 50 milligram dose. So the 10 kg weight loss, so nearly, if you look, this is the 10% weight loss because average, the mean body weight was 94 kg. And now you can see minus 9.2 kg. So nearly 10% weight loss happened with the 50 milligram of oral semaglutide. This is too good to look at when you are looking at a anti-diabetes drug having a potential to become an anti-obesity drug. Now, the second part is whether this was done or this was achieved at the cost of an increased safety issues. What was interesting to note that although the GI adverse event were little more frequent, and this is expected if you use the higher strength of GLP-1 by virtue of how it works, you expect an increase in nausea and vomiting. So, although the proportion of patients receiving higher strength of oral semaglutide, such as 25 and 50 milligram, had higher proportion of people having nausea and vomiting, but it was not quite statistically larger compared to the 14 milligram, and that was very reassuring. And as you can see, even these higher strength of 25 and 50 milligram were well tolerated in the Pioneer Plus trial. So to conclude about the Pioneer Plus trial, what we learned in this phase 3B double-blind randomized controlled trial, that the higher strength of oral semaglutide 25 and 50 milligram was superior to the conventionally recommended oral semaglutide 14 milligram, not only in terms of HbA1c reduction, but also in terms of reducing body. And that was nearly 10% weight loss with the 50 milligram was unexpected. Remember, in people with type 2 diabetes, you tend to lose body weight less compared to people with obesity without type 2 diabetes. And there are many reasons behind that. I'm not going to detail here. And I will show you in the original anti-obesity trial of oral semaglutide, which I'm going to present next, in Oasis, even body weight was quite larger compared to the Pioneer Plus trial. But even in a type 2 diabetic patients, 10% weight loss with anti-diabetic drug is quite remarkable. So let's hit to the next trial, because the making 50 milligram of oral semaglutide was basically to look at the anti-obesity potential of the drug, and keeping in mind this primary objective, the Oasis 1 trial was compared in people with overweight and obesity compared to placebo. So the Oasis 1 is a double-blind randomized controlled placebo-controlled trial that compared the highest strength of oral semaglutide 50 milligram in people with obesity defined as BMI more than 30 kilogram per square meter, or BMI more than 27 with one risk factor. As you can see, this was the inclusion criteria for an anti-obesity trial. And here people were randomized in 1:1 fashion, oral semaglutide 50 milligram. Rule of game is similar. You can't start with 50 milligram straightforward. You start with 3 milligram once, then 7 milligram after 1 month, then to 14, then to 25. You have to escalate the dose, starting from classical 3 milligram to 7 to 14 to 25, and then to 50. As you can appreciate, it would take 5 months to go to from 3 to 50 milligram. So that's why this was the dose escalation phase of oral semaglutide. And similarly, the placebo arm were done in a similar fashion to make it a, double-blind randomized. And this trial, as you can see, went ahead for 68 weeks. So 52 weeks of the trial and 16 weeks of dose escalation. So 1 year again trial with a 16 weeks of dose escalation from 3 milligram to 50 milligram. The primary outcome of the study was to look for, safety and efficacy of this 50 milligram oral semaglutide in people with obesity or overweight without type 2 diabetes. So these are classical obesity trial with the oral semaglutide. Remember, there is another trial going on called Oasis 2. Now we are presenting the result of Oasis 1. These are the co-primary endpoints. So the percentage of patients with weight loss of more than 5%, this would be peanuts for this particular trial. Even oral semaglutide 14 milligram had good number of people, more than 50% achieving the more than 5% weight loss. And these are the secondary endpoints of more than 10, 15, and 20% weight loss at the end of 52 weeks of final dose escalation phase is over. So that's what the Oasis trial looked like. Now, if you look at the baseline characteristics, as you can see, this is a predominantly male-dominant trial, so 74% in the oral semaglutide and more than 70% of male population. Age nearly 50 years, and primarily these trials were conducted in, Northern America, so the maximum of white population. If you look at the baseline characteristic, that's because it's an obesity trial. I told you in the Pioneer Plus, the mean body weight was 94 kg, it is 104 kg, so 10 kilo higher, classical, obesity trial. So these are the people who are having a BMI of more than 30. As you can see, mean BMI was 37, but it was matched fairly between the oral semaglutide and the placebo arm. As you can see, the mean HbA1c, they were not people with type 2 diabetes having HbA1c of less than 5.7, so mean HbA1c was 5.6. Now, if you look at the primary outcome of this study, so here is the body weight reduction. Look at the weight loss. Now, this is 17.4%. And as I told you, in the Pioneer Plus, 50 milligram oral semaglutide reduced body weight by 10 kg. Here it is 17.4. If you look at, the placebo subtracted, interestingly, when placebo arm had 1.8% weight loss. So if you look at the placebo subtracted, the body weight loss was nearly 16% from the baseline. Now, in the Pioneer Plus trial, this body weight loss was nearly exactly 9.5%. So you can see twice 9.5 and 17.4% weight loss with oral semaglutide in people with obesity. It was huge. If you look at the current anti-diabetes drug, which is approved, starting from orlistat to naltrexone, bupropion, or phentermine, topiramate to liraglutide, 3 milligram to semaglutide, 2.4 milligram. And I will show you even injectable Wegovy 2.4 milligrams data comparing the oral, semaglutide 50 milligram. If you look at the secondary outcome, so this was the co-secondary outcome, more than 5% weight loss. Nearly 90% of the population receiving oral semaglutide had more than 5% weight loss. And this is expected. I am not amazed. As I said, even in, Pioneer 1, there was, 45% of people had HbA1c of, body weight of 5% weight loss with the 14 milligrams semaglutide. So you expect, at least twice more with 50 milligram, and exactly 90% people lost 5% weight with 50 milligram of oral semaglutide. Now, if you look at the safety outcome, of course, people receiving oral semaglutide had a proportionately higher side effect. But what is interesting to note that even the placebo arm, and I am sometimes amazed, I don't understand, to be very frank with all of you, that how could in a trials, the placebo arm, this perhaps looks like a nocebo effect rather than the drug effect. How could the placebo arm should have a similar overall adverse event compared to the oral semaglutide? So you can see nearly 85.6% of people receiving placebo If you look at the GI side effect, the GI side effect happened in nearly 50% patient receiving placebo. It's fine. 80% of people with oral semaglutide had GI side effect. That is acceptable. But even the placebo arm had got, 50% of placebo arm had, GI related reversible. And I am sometimes surprised how it happens in these trials. Nevertheless, this has happened. And there is no point of raising any question because these are double-blind trials. So what is interesting to note that overall adverse event in terms of safety and tolerability was not that much greater, unacceptably greater with the higher strength of oral semaglutide 50 milligram compared to placebo. And this is how this text read likes that. You can see that it was fairly well tolerated, 50 milligram. Of course, the most common side effect, what GI side effect. And what was interesting to note, if you look at the people, discontinued the drug, and that was pretty interesting. I expected even a larger number of percentage of people to, withdraw, considering the GI side effect of GLP-1, at a large. But you can see 4%. It is nothing. Of only 4%, withdrawn from the study because of the GI side effect, which was 1.5% even with the placebo. So if you deduce 3.6 and 1.5, 2% additional people withdraw from the study, only 2%. So basically 100 of 100, only 2 left because of GI side effect. 98 continued with the oral semaglutide. That is very fascinating to look at this data, and therefore they concluded that the adverse event was reasonably, acceptable compared to placebo in the Oasis 1. And so to give you the final conclusion of the Oasis 1 trial, for the first time, we have got a higher strength oral semaglutide 50 milligram, was shown a significant weight loss compared to placebo in a people with obesity or overweight without type 2 diabetes, with an acceptable safety profile compared to placebo. Now, this brings out that then how to place this molecule. And I thought to give you, this paper was published just yesterday, as you can see in the Nature Medicine, looking at all the newer modern anti-obesity drug, second generation anti-obesity drug, which you perhaps heard, which was presented during the last ADA. And this includes these new class of drug, starting from the non-peptide GLP-1 orforglipron. And in this trial, you could see these are the highest licensed dose in their phase 2 trial. Remember, barring semaglutide, oral or injectable, or tirzepatide, whatever new drug you are seeing are their phase 2 trial data. And in this paper, they compared their highest, dose of phase 2 study. So if you look at all these newer class of second generation anti-obesity drug, and if you compare the oral semaglutide, what is interesting to note here, on your left-hand side is the data in people with obesity or overweight, and your right-hand side is the data in people with type 2 diabetes, with or without obesity. Now, if you look at the oral semaglutide in the context of all the newer generation anti-obesity drug, remember, barring injectable semaglutide, which is Wegovy, we don't have any approved anti-obesity drug in this particular chart. We expect tirzepatide to get a very quick US FDA approval for obesity, although the tirzepatide is approved in type 2 diabetes, but it is not yet approved in obesity. But we do expect that the tirzepatide would be given US FDA approval soon. So if you look at this chart and imagine that all the drugs here, which is undergoing phase 2 trial, in their phase 3 trial gets a significant body weight lowering. And if we assume that all those drugs get FDA approval in their maximum licensed dose, how the chart would look like. Now, the oral semaglutide, what is interesting to note, was nearly similar to the injectable semaglutide. So as you can see, this is the weight lowering potential of Wegovy, which is approved as an anti-obesity drug, 17 kg weight loss. The oral semaglutide in Oasis was shown 17.4 kg in people with obesity. So here you have got an oral drug which is showing a similar weight lowering potential like a once weekly injectable, clearly giving you a hint that in future you don't need to inject even anti-obesity drug. You might get an oral drug that would give you a similar weight loss like a injectable semaglutide. Similarly, if you look at people with type 2 diabetes, and interestingly, when I made a comment that weight loss are always smaller in people with type 2 diabetes compared to people with obesity, you can see across all the second generation newer anti-obesity drug, the weight loss are relatively smaller in people with type 2 diabetes compared to people with obesity. The basic reason is, first reason is very obvious, because these are the trials who has got a trials where people have got a mean BMI or body weight quite larger than people with type 2. That's the first basic simple reason. The larger the baseline body weight, larger is the weight loss you expect with the drug. That's the first rule of game, why you find a major larger weight loss in people with obesity. And there could be other reason I'm not going to today. So what we saw that through this Pioneer Plus trial in people with type 2 diabetes and Oasis 1 in obesity, quite a significant weight loss. Not only the HbA1c reduction by minus 2.2%, you have got an additionally 10 kg weight loss in people with type 2 diabetes, nearly 17 kg weight loss in people with obesity. Oral semaglutide 50 milligram seems to have a bright future. Thank you very much for your patience.
Thank you, sir. Thank you for taking us through the Pioneer Plus and Oasis 1 data extensively. And thank you for also letting us know about the implications of such a massive weight loss and what is the difference between these trials between type 2 diabetes and also among patients with obesity. And also showing us the importance of oral molecule giving us such a large proportion of weight loss compared to injectables. Thank you, sir. Sir, I would like to ask you the few questions from audience side. So the one is, so with this massive reduction of weight loss coming up with these oral molecules, will this have an impact on remission of diabetes in patients with early diabetes?
Yeah. So that's very fascinating question. We have to wait for that. Okay, so remission and type 2 diabetes, of course, been linked to the weight loss, but we need to generate data. We do expect that if you have a weight loss in a tune of, more than 10%, there is a likelihood of type 2 diabetes remission is larger, but then we need to really conduct the trial. We do have data from, bariatric surgery. We have got data from the intensive lifestyle modification. But for the drugs, anti-obesity drug, we need to generate those data. We don't have, conclusive evidence at the moment to recommend remission of type 2 diabetes. But looking at the evidence generated with the bariatric surgery, people having 20-25% weight loss had a quite significant remission of diabetes. Here also you have got 15-17% weight loss, nearly 20% weight loss. So we do expect remission of diabetes, but we need to generate data.
Dr. Avdesh, two people have asked a question here on the chat. One is, many times thyroid and semaglutide has to be given together. Both have to be given on empty stomach. So can they be both given together, number one? Or otherwise, how it has to be given? Number two, are 2 tablets of 7 milligrams equal to 14 milligrams, or you need to give 14 milligrams separate?
Yeah, that's very good question. So the first question is known to all of us that during the PK/PD study of oral semaglutide with various drugs, it was found that if you take levothyroxine with the oral semaglutide, somehow it increases the bioavailability to 33%. So we are not supposed to use levothyroxine with oral semaglutide. So the current recommendation is that if you have got a patient with hypothyroid, having type 2 diabetes, and you wish to start oral semaglutide, don't give levothyroxine, until 30 minutes has passed after oral semaglutide. So what we do is that we suggest patient to take oral semaglutide first in empty stomach after the patient gets up. You wait for 30 minutes, then you can take thyroxine tablet. Ideally, you wait further 40-45 minutes for levothyroxine to get out of your stomach, and then you take breakfast. So this is one way to go at. The second could be that if patient is in hurry, many office going people might not wait for 2 drugs to go for 30 minutes gap. So we might suggest many patients to take thyroxine tablet when they get up in the morning, or someone can take it 3 hours after the dinner if they are incidentally working. So there are several ways to go for thyroxine in people with oral, in someone who is taking oral semaglutide. The second question was, I just missed it.
Two tablets of 7 milligrams.
Yeah. No, so Indian Jogaru type of nature doesn't work. Remember, this is a peptide, and there is a proportionate dosage of snack with every tablet. So if you want to give 14 milligram, first of all, it is a fully supposed to give 2 tablets of 7 milligram to make it 14, because you basically increasing the cost by twice. The 14 milligram and 7 milligram has got nearly same cost. And first of all, as I said, the snack proportion of every strength of oral semaglutide is different. So you can't the 3 plus 3 doesn't make 6 in the oral semaglutide, or 7 plus 7 doesn't make 14 milligram. So for the 50s, let's say if someone think that, okay, we don't have 50 milligram, so why not use 14 milligram 3 tablets? This might work in people with obesity. So that's not the answer. You won't get at all any response with if you give 3 tablet of Ribelsus 14 milligram with a feeling that it will make it a 42 milligram, and we can reduce the body weight by 10%. That doesn't work. You need to have an exact dose of 50 milligram with that proportion of snack. So answer is not at all. You should do it.
Thank you so much, Avdesh. Dr. Sumati, any more questions?
Yes, sir. There is one more question. With these massive weight reductions with available injectables and oral molecules and upcoming molecules, how does it place bariatric surgery in the treatment of obesity?
Yeah, so that's very interesting. Yeah, 6 months back, we couldn't believe that we may have agent like anti-obesity drug, which can closely compete with bariatric surgery. But look at the newer molecule like oral semaglutide, for example, tirzepatide, even injectable semaglutide. If you look at the triple agonists like retatrutide, GIP, GLP-1, and glucagon, triple agonist, they are nearly, if you look at the retatrutide data, 24% weight loss. So we are competing now really with bariatric surgery. Indeed, if you look at some of the bariatric surgery has got a different procedure. If you look at the malabsorptive procedure of bariatric surgery, like classical RYGB, where you have got a 30% weight loss, we are nearly approaching with these drugs, with tirzepatide or retatrutide, we are nearly competing with RYGB kind of bariatric surgery. If you are comparing with a minimally invasive surgery like lap bending, etc., these drugs seems to be even better than the minimally invasive bariatric surgery. So I do feel that in future these molecules would compete for the bariatric surgery. Of course, one invasive approach versus a non-invasive approach. Anytime people would prefer these newer second generation anti-obesity drug over bariatric surgery. And I do feel the time is not far where bariatric surgeon has to wait with a scalpel in hand if these drugs are really available for the clinical use across the world.
Thank you, sir. Thank you for your wonderful session and answering all our questions.
Thank you. Thank you so much.
Thank you, Avdesh. Go ahead, Sumati.
Yes. So with this, we
You're on mute.
move on to our next session, the major advances in diabetes and updates in the recent ADA standard of care. For this, we have the session by Dr. Uday Fatke, who is a consultant endocrinologist from Shayadri Super Speciality Hospital, Pune, and he is the member of the American Association of Clinical Endocrinologists and lifetime member of Endocrine Society of India. He is the faculty in more than 1,000 national and international meetings related to diabetes and endocrinology, and he's been awarded conjoint clinical teaching fellowship in the Faculty of Health, University of Newcastle, Australia. He is the course designer and director of a program called Clinical Endocrine Update that engages more than 200 physicians every year. He is also has postgraduate teaching experience, and he has done in the certificate course of diabetes under the auspicious College of Physicians of India, and he has authored multiple articles on diabetes and published in international and journals as well, and contributed chapters on diabetes care in RSSDI textbook of diabetes and other books dedicated to diabetes. So let's move on to the session by Dr. Uday Phadke on the recent updates.
Good afternoon, everyone. So, in the next 20 minutes or so, I will be discussing with you some of the major advances in diabetes and some updates that were discussed in the American Diabetes Association's annual meeting, and some things which have been included now in the standard of care in diabetes recently. The first one is some of the advances in type 1 diabetes, and this is interesting because we have not had too many advances about type 1 diabetes in the past couple of years, and management has more or less remained the same. This is something which is a bit of a revival, and we are revisiting this molecule again, and that is teplizumab. This teplizumab is a anti-CD3 antibody, and this is a monoclonal antibody which binds to the CD3 antigens which are presented on the surface of T cells and which eventually bring about the autoimmune destruction of the beta cells, which finally leads to serious insulin deficiency and type 1 diabetes. Now, some of you might recall that teplizumab was used several years earlier, maybe a decade earlier, to try and reverse clinically manifested type 1 diabetes of short duration, and that was called the Protege trial. And I was a part of that trial as well at that time. We had significant number of side effects also with the drug, and somehow when this drug was used in clinically manifest type 1 diabetes, there wasn't a very great reduction in people going to an insulin free status at the end of 1 year after the course of teplizumab was given. But it did set the stage to think that some of these immune modulatory therapies might work in an autoimmune disease like type 1 diabetes. And now we have what the other part of this trial which has come up. And now it is slightly different. We are now using this to prevent the progression of stage 2 type 1 disease to stage 3 type 1 diabetes. So, stage 1 of type 1 diabetes means only at risk with multiple antibodies positive and probably a family history or some proband in the family who has type 1 diabetes. So, basically, at risk patients. Stage 2 is where the sugars do or the glucose does start to go up, but there is no clinical disease as yet. And stage 3, of course, is the full blown, frank, clinically overt type 1 diabetes. So here, teplizumab was given, and what we feel now is that there might be a reduction in conversion of stage 2 to stage 3 disease, and the US FDA has approved teplizumab for use in this particular indication. The other exciting thing in type 1 diabetes is the bionic pancreas. So, the bionic pancreas is nothing but another form of artificial pancreas, what is called a closed loop system. Essentially, a closed loop system means that there is a sensor. The sensor is connected to a device which releases insulin continuously inside the body, which is basically a pump. So it's like a sensor augmented pump, but totally driven by a large amount of data driven points derived on artificial intelligence. And One of the first to be launched was the Medtronic 780G system, which is also called the Advanced Hybrid Closed Loop System. And we already have some first hand experience on that. So, the bionic pancreas is another such automated insulin delivery system. The good part about the bionic system right now is that the patient is not supposed to put in any input. So, no inputs from the patient is required. And just fitting the device and allowing it to run will still produce a significant reduction in glycosylated hemoglobin, as you can see from this particular slide. And no matter where we start from, there's a significant reduction in glycosylated hemoglobin, a clear improvement in the time in range, and all this without having the need for the patient to provide inputs for the patient. You don't need to seriously uh, start carb counting. A broad estimate of carbohydrates, as small, medium, and large, is good enough for the bionic pancreas to decide on the dose of the bolus insulin that is given at the time of meals. And right now, the bionic pancreas is available as insulin only. But it's just a question of time when we will have the dual bionic, that means both insulin as well as glucagon. So, this is another important advance in type 1 diabetes. There are also some things lacking in type 1, and that is lack of data on GLP-1 receptor agonists and SGLT2 inhibitors for obesity, cardiovascular disease, CKD, and heart failure in type 1. So, even type 1 patients are at risk of developing all these disorders. But hitherto, there was no real data on what we could do for all these disorders. And let me tell you that there is a lot of work going on in these, and some data is emerging on SGLT2 inhibitors and GLP-1 receptor agonists, particularly for obese type 1 diabetic patients who have some amount of C peptide secretion still left. There are also several advances which were reported in type 2 diabetes. And one of the important things that is now being recognized is that diabetes is not only about treating blood glucose, it's also about weight reduction simultaneously. And that helps the best in bringing about a reduction in the cardiovascular outcomes. So we have several things now that are coming up in type 2 diabetes. One, of course, on the insulin front is once weekly insulin, a long acting basal. We have oral GLP-1 receptor agonists, which we did not have earlier. We only had the injectable ones, oral semaglutide. And now, of course, as I said, for this combined approach of targeting diabetes as well as obesity, we have the dual as well as the triple agonist approaches. So, which has GLP plus GIP1 combination, and in one particular instance, a triple combination of GLP1, GIP, and glucagon. If you look at semaglutide injectable, this has now been approved as weight loss therapy for adolescents aged 12 years and above. I think this is very important because we see a lot of adolescent obesity, and these are the ones who will finally become obese adults and will develop diabetes at a much larger they are at much larger risk for developing diabetes. So treating them early clearly matters. So semaglutide and phentermine topiramate, which is either to be in use, of course it's not available in India, but these are now approved for adolescents aged 12 and above. Basal insulin has undergone a lot of innovation. The first basal insulin, of course, was NPH, which is also a basal analog of insulin because it has been chemically modified to delay or prolong its action. But we know that half-life was only 5 to 10 hours and therefore had to be given once or at least twice a day, often twice a day. Then came the first generation basal insulin analogs, which again had a slightly longer half-life, but still not, we cannot call them really true long-acting basal analogs. And they again had to be administered often twice to have good effect. Then we have the ultra long acting basal insulin analogs, which have actions for at least 24 hours and more, really. And we have degludec, and we have the long acting glargine 300 in this particular uh, basket. And now after that, but this still requires once a day injection to improve patient compliance, to reduce injection burden, to improve overall control. People have been working on once a week basal insulin, and that now seems to be coming to fruition. And we now can talk about once a week basal insulin. If you look at the differences of once a week versus once daily basal insulin therapy, we know that clinically the glycemic control is the same, in fact, with lower hypoglycemia risk because it's a very, very flat insulin. Obviously, there is a reduced treatment burden. There is a reduced treatment burden, and obviously, therefore, it is easier to overcome the therapeutic inertia. Obviously, one injection is always better than 7 injections. On the molecular side, the half-life is clearly longer, much more stable PK and PD behavior, and a much smaller or much slower clearance rate. Clearly, obviously, I think there will be better treatment acceptance and adherence. And I have seen a lot of data coming from these early trials, and it looks as if this once a week basal insulin will be here shortly and will be staying as one of the very important advances in treating insulin requiring type 2 diabetic patients. If you look at what all has come for diabetes treatment in type 2 diabetes, you will see a lot of new additions to treatment, practically 40 new treatment options approved by the FDA since 2005. And of course, if we trace the whole journey of type 2 diabetes treatment, starting from insulin almost a century ago, followed by sulfonylureas, metformin, alpha glucosidase inhibitors, thiazolidinediones, meglitinides, GLP-1 receptor agonists, SGLT2 inhibitors, and so on. The line of these particular drugs has continuously remained to be in increasing proportions and helping patients all around. And yet, despite availability of all these numerous treatments, we see that the global burden of diabetes persists. Diabetes is still the ninth major cause of death globally. More than 50% still develop microvascular complications. More than 25%, I would say roughly about 30 to 35%, develop macrovascular complication, and this number goes on increasing as the duration of diabetes increases. And at least 25% of people develop CKD. And again, as the duration of diabetes goes up, more number of people develop CKD, and CKD is one of the most difficult things to treat over a long period of time. So management still remains a challenge, and the quest for an ideal anti-diabetic drug continues. And I'm sure you'll all agree that there cannot be one single anti-diabetic drug which is ideal for all people, because we not only need to reduce the glycemic problems, but we also need to minimize the hypoglycemia risk. We need to reduce the side effects. We need to reduce the complexity of use. We need to improve patient preference and adherence. We should also be targeting, and very importantly so, comorbidities like CKD, CVD, etc. It should be weight neutral. In fact, it should be weight loss promoting, and it should have other non-glycemic effects as well. That means it should be helpful to reduce maybe liver fat. It should be helpful to reduce blood pressure. It should be helpful to reduce the chances of, say, congestive heart failure. And all of this is difficult to find in a single drug. But if you look at the GLP-1 receptor agonists, this group of drugs addresses at least 6 out of these 8 octet mechanisms. So if you look closely in the pancreas, it not only improves insulin biosynthesis and the beta cell function, but it reduces glucagon secretion as well. It slows down gastric emptying, and therefore the passage of glucose is slowed down, so the postprandial peaks go down. In the kidney, it offers nephroprotection and albuminuria reduction. In the periphery, in the muscles, it improves insulin sensitivity. Its very important role in the liver includes reduction in steatosis and improvement in hepatic insulin sensitivity and reduction in hepatic glucose production. And as I was saying earlier, it has a very clear non glycemic benefit, and that is cardioprotection and vascular protection. And of course, it also acts on the brain to suppress the feeding center. It improves satiety and clearly reduces body weight. So, on all counts, I think this is a very important group of drugs which covers or ticks a lot of boxes which are important in type 2 diabetes. 60% of patients with type 2 diabetes would then qualify for a GLP-1 receptor agonist. If you look at all the indications, steatosis, obesity, type 2 diabetes, elevated postprandial sugars, cardiac risk, renal risk. However, if we see, only less than 10% of people who actually need the GLP-1 are receiving GLP-1 receptor agonists in clinical practice. And of course, there could be several causes to it or factors to it. But injection fear is one of the major barriers for initiating GLP-1 RAs early in the course of disease. And people do think that non-invasive approach can improve compliance and allow early initiation. And I think this particular thing does stand to logic, because if you look at the use of the injectable GLP-1 receptor agonists in India, and now compared to the uptake of this particular molecule after the launch of the oral GLP-1 receptor agonist molecules, clearly there is a much improved use of the GLP-1 receptor agonist after the oral GLP-1 receptor agonists were brought into the market. So clearly, I think there is an improvement. This has been the holy grail, and that is oral insulin in type 2 diabetes. People have struggled to produce oral insulin, and somehow, after variety of methods being used, trying to envelop the insulin molecules into variety of biospheres, cubosomes, and everything, somehow using pulmonary insulin, nasal insulin, somehow oral insulin still is not available. It is still nowhere near completion of human trials. And it looks difficult because there are a lot of things which break down oral or make oral insulin difficult, and particularly the gastric pH and the proteases which are present in the stomach immediately destroy peptide molecules. So, with this background in mind, oral GLP-1 also seemed quite impossible because of the very factors which make oral insulin so difficult. So, degradation, as I said, low pH in the stomach, proteolytic enzymes, limited permeability across the gastrointestinal epithelium, and a very low bioavailability, therefore. Even with insulin's oral, you might have to give, say, 100 or 200 units equivalent of insulin just for 1 unit of insulin to actually reach the blood vessel. So, again, this very poor bioavailability becomes an important factor, was considered an important factor. And oral GLP-1 receptor agonists seem to be really a dream, but they are clearly not. And as we know now, oral semaglutide, which is a 94% homology to human GLP-1 with a T half of approximately 1 week, is now available in the market. And how was this achieved? This was achieved through some brilliant bioengineering work by scientists, where they combined the semaglutide to a absorption enhancer, which is called SNAC, which is basically sodium aminocaprylate. And what this particular sodium aminocaprylate does is it creates a small area in the gastric epithelium where the semaglutide molecule, where the pH locally changes, the permeability locally changes, and semaglutide quickly is able to absorb into the bloodstream through that particular window, and then the whole thing shuts down again. So this is brilliant bioengineering, and We are therefore able to give semaglutide orally. Of course, there are some things to follow. We need to give it in the empty stomach with a clear mentioned quantity of water, which is about 120 ml. And we should not be giving anything to eat or drink after the medicine is taken for at least 30 to 45 minutes. And then, of course, the patients could eat with remarkable benefit seen in a number of things: reduced energy intake, hunger and the frequency of cravings, improved satiety and fullness, and improved control of eating, and therefore, of course, reduced body weight and clearly much improved blood sugar control. So, what may change the diabetes world as we know it? So, teplizumab, as I said, potential to transform type 1 diabetes care by focusing on early screening and intervention. So, the moment we find a type 1 diabetes case, our responsibility doesn't end there. So his close relatives need to be screened and followed up. And the moment we have stage 1, stage 2 disease, they could be offered teplizumab later to stop progression into stage 3 disease. Bionic pancreas, as I said, the artificial pancreas, which more or less is closing the loop and does not require any input from the patient, and it simplifies automated insulin delivery, clearly makes diabetes care for type 1 diabetes more accessible for primary care doctors. And as if the last thing was weight management. So anti-diabetic agents with weight loss benefits like semaglutide may revolutionize weight management in people with diabetes. So the key updates in ADA 2023, where you can see here in the prevention or delaying of type 2 diabetes, it was identification of high risk population, referral of high risk populations with overweight or obesity, and putting them into more intensive intervention so that they don't go to clinical diabetes. Then we had some goal settings for treatment decision making in type 2 diabetes, where the focus on treatment, apart from glycemic reduction, was renal risk reduction by using therapies like GLP-1 receptor agonists, and consideration of individual goals, barriers, and circumstances in therapy selection. Obviously, in CKD risk management, we are going to use the newer anti-diabetic therapies which have been proven to be of benefit. Not only the SGLT2 inhibitors, but consideration of non-steroidal mineralocorticoid receptor antagonists for CKD and cardiovascular risk, and of course emphasis on ongoing monitoring and referral to nephrologists for evaluation and collaborative care. So if you look at the standards of care in diabetes, the new recommendations clearly say achieving more intensive weight loss goals using newer medications and targeting lower blood pressure and cholesterol goals. Now, if you recall, the direct study, that is the diabetes remission clinical trial, did show a marked amount of remission or temporary resolution of the glycemia in people on low calorie diets. Please do remember, however, that new findings from a 3-year extension of the direct study show that less than 25% of participants who were in remission from type 2 diabetes at the end of 2 years remained in remission at the end of 3 years. So it means that you could have temporary remissions. However, permanent remissions or very long-term remissions are not possible, which means drugs still have a lot of importance and potential in use in type 2 diabetes. So everything, although lifestyle is very important, medications are clearly important in weight loss benefits and also for improved diabetes management. We have seen this slide several number of times, and it just clearly re-emphasizes that when you look at a type 2 diabetes, we cannot just randomly select drugs. So those who have established ASCVD or cardiorenal or renal disease, or those who are at high risk for developing these two disorders, or those who have heart failure or left ventricular dysfunction. By definition now, or by clear guidelines now. They should be on a GLP-1 receptor agonist or a SGLT2 inhibitor with proven CVD benefits as one of the drugs at least, if not both. And if then the HbA1c is above target, you could use all the other available agents, because all the available agents apart from these two don't clearly cause any specific organ benefit. So whether it is the gliptins or whether it is sulfonylureas, they are not cardiac risk producers, but they do not produce any specific cardiac benefit over and above what would happen with just glycemic measurement. So I think this is very, very important to identify these people with high risk and remember that the use of GLP-1 or SGLT2 should be independent of background use of metformin. It's nowhere now recommended that metformin must be the starting treatment. And of course, when choosing oral glucose lowering therapies, you will be benefited in choosing regimens with very high dual weight and glucose lowering options. One of them, of course, is semaglutide. So thank you very much for allowing me to share some of these updates with you.
Thank you, sir. Thank you so much for the excellent session and taking us through the newer concepts which might change the world of diabetes, such as teplizumab, bionic pancreas, and the newer receptor agonist molecules like single agonist, dual agonist, and triple agonist, and also by taking us through the recent updates in the guidelines of ADA, focusing on cardiorenal risk reduction and using molecules with higher weight reduction for management of type 2 diabetes, as it has multiple other potential to reduce the long-term complications. Thank you, sir. With this, we'll move on to our next session. So next session is a no notice session for which we are going to, can you go back to the previous slide, please? Dr. Krishna Sheshadri will take us through the session. He is the professor of endocrinology and medical education and board member of Sri Balaji Vidyapet and MGM Health Center. And he is an American board certified endocrinologist, diabetes and metabolism consultant in endocrinology and diabetes. He has done multiple clinical research, and he is the clinical research lead in Apollo Sugar, and he is senior consultant in Apollo Hospitals. He has funded transitional research currently on circadian rhythms and metabolism, and he is the associate editor of Journal of Diabetes in Developing Countries. He is the editor-in-chief of Thyroid Research in Practice, member in Indian Journal of Endocrinology and Metabolism. He is a member in the Curriculum Expert Group of National Medical Council, and he has received awards like P.N. Shah Oration of the Endocrine Society and Sam G.P. Moses Oration of RSSDI and Sindhu Pandit Oration in Medical Education. So with this, we'll move on to the session of Dr. Krishna Sheshadri, who will take us through the real-world evidence of oral semaglutide, that is RELATE, and the one more session with dual therapy of SGLT2 plus GLP-1 receptor agonist. On to the session, please.
Hello, and thank you for asking me to be part of this important meeting. Real-world studies are an important addition to our evidence base. They provide a validation that what works in the track of Indianapolis works in the streets of Mumbai. In what works in the controlled environment, where adherence is high, where coaches are present in RCTs. Also works when patients don't take medications properly. There's nobody calling them back to see if they're taking the medications. They also provide certain other insights that are really not possible in RCT, because the scope of an RCT is a very narrow question. It answers something that's very narrow, and usually answers only that much. More than that, they are hypothesis generated. RWEs are in many ways able to answer some of these questions. They're not the highest level of evidence, but they point us in the direction of where and how we need to position things in practice. So in this update, let's talk about a couple of studies. that bring in the real world impact of GLP-1 RAs. The first one is the real world impact of oral semaglutide on glycemic control and weight outcomes in type 2 diabetes, called the RELATE study. The objective and design was to evaluate the impact of oral semaglutide for type 2 diabetes on changes in A1C and weight outcomes. It's a real-world observational study that was done from 2019 October to 2021 using patient databases, and they compared HbA1c and weight-related outcomes at the baseline and after 12 months. The mean was around 59 years of age. Half of these were women. The mean age was 102, so about 25% having a, and 75 of them having a BMI of greater than 35. So the first question for the audience is, what is your expectation of mean A1C reduction from baseline of 8.8 and weight loss from a baseline weight of 102.4 kgs from this real world study of 1 year duration? Is it A, mean A1C reduction of less than 0.5 and a weight loss of less than 3, B, 0.5 to 1% and mean weight loss of less than 3, C, 0.5 to 1 and mean weight loss of 3 to 5 kg, and D, A1C of 1 to 1.5 with a mean weight loss of 3 to 5 kg. You can answer now. So let's look at this data. At baseline, the A1C was greater than 8. At the end of 12 months, the A1C was 7.8, an A1C reduction of 1.5%. That was statistically significant versus the baseline. But a third of the patients achieved an A1C of less than 7. Remember, the baseline was 9-ish, and 32.4% had an A1C of less than 7. About 3.3% achieved less than pre-diabetes numbers, right? And 13% had 5.7 to 6.5, and the rest around 6.5 to 7. This is quite impressive and consistent with our knowledge about using GLP-1 receptor analogs, that these are really agents that push the A1Cs down in a certain section of the patient population. In addition, there was a significant weight loss with oral semaglutide. Remember, the greater the BMI, the greater the weight loss. The initial weight was 102, and at the end of the year, the average weight was around 98.9, which is again statistically significant versus baseline. More than 70% of patients achieved weight loss in 12 months. And very interestingly, for those of us who are thinking about the significance of 10% as reducing complications, as reducing inflammation, and 15% as even leading to remission, you will see that about 10% of patients had a weight loss of more than 10%. Greater than 30% had a weight loss of more than 5%, and about 3.5% had greater than 15% weight loss. Impressive numbers, actually, given that we are using oral semaglutide. And this is looking at the BMI reduction. Remember that greater than 2 to 3 points reduction in the BMI is considered to be very useful. And you will notice that at the baseline, about 75% of the patients had obesity that was class 1 or greater, right? And you will see that number came down to 70%. So clearly, the number of patients who were in remember that the obesity reduced in the highest categories. So the number of patients in class 3 came down by almost 5%, a 2% reduction in class 2, and a slight increase in class 1. That generally means that the patients with the higher indices were pushed down. So here is the answer to the question. The correct answer is D, A1C reduction of 1 to 1.5% with a mean loss of 3 to 5 kg. The actual A1C reduction was about 1.1%, and weight loss was greater than 3.5 kg in 1 year. So in a real world setting like yours and mine, with slightly greater weight than our population generally, 12 months post-index, patients with oral semaglutide achieved statistically significant reduction in A1C, body weight and BMI levels as compared to the baseline. 32% met the A1C goal of less than 7%, 33% met the weight body goal of greater than 5%, and importantly 10% surpassed the body weight goal of greater than 10%. So let's move on. And the second trial that I'm going to talk about is something that many of us have a good experience with, and that is a combination of GLP-1RA and SGLT2 inhibitor. I remember Dr. Nock writing an editorial saying that a marriage of GLP-1RA and SGLT2 inhibitor is both desirable and inevitable. And that's exactly what the authors of this particular study looked at, and especially at the renal and the CV outcomes. So the aim is to use GLP-1 receptor agonists and SGLT2 inhibitors. There is no real data on real-world evidence, despite our interest in this. It was to compare the use of GLP-1RA and SGLT2 to other dual second-line therapies with respect to renal and CV outcomes. This was a real-world study that looked at a nationwide registry between 2010 to 2021, patients on two second-line type 2 diabetes treatment. They looked at chronic renal disease, ESRD, a greater than 50% decrease in EGFR. An estimated risk following one of four therapy was determined using longitudinal causal inference framework. One is a DPP4 SU TZD with a reference group, and then the groups that included GLP-1 plus SGLT2, GLP-1 plus one of the three DPP4 SU TZD, and the next group was SGLT2 plus DPP4 SU and TZD. The CV outcomes: primary outcome was heart failure, the secondary outcome was MACE and all-cause death, and the estimated risk of following one of four therapy was determined as I outlined in the previous slide. Let's look at the baseline demographics. In the reference group, 59% were male, 3% were on insulin, 7% with heart failure, 69% on statins, 39% greater than 70 years, 23% had higher income. In the GLP-1RA with SGLT2 inhibitor, the numbers were similar. The important thing was a slightly higher percentage of patients with higher income and a lower number greater than 70. Similar with the GLP-1RA plus one of the three, and a little more older group of patients in the SGLT2 plus the others. But otherwise, these looked evenly matched. So let's look at the data. So here is the dual therapy GLP-1 plus SGLT2 inhibitor compared to the reference therapy. There was a significantly lower risk of ESRD and an EGFR risk of greater than 50%. There was a similar risk reduction seen for chronic renal disease when compared to it. And you'll notice that these are pretty much outlying, and you can see a beautiful, let me go back, sorry. You can see the values here, 0.12, upper limit of confidence interval of 0.15 when GLP-1RAs were involved with ESRD. And similarly, GLP-1RA had a greater benefit when compared with DPP4 and SU, when combined with DPP4 and SUs. Not so much with SGLT2 and the others. And you will notice in the EGFR greater than 50%, it's only the GLP-1RA and SGLT2 that had upper limit of confidence interval of 0.59, a lower limit of 0.45. Really impressive data. Again, remember, these are all both real-world studies. They are not at the highest level of evidence, but fairly indicative of what we're trying to do. When you look at heart failure, again, you will look at it. The MACE, the dual therapy did better. Upper limit of confidence interval of 0.95. And again, along with others also, the upper limit of confidence interval was 0.98, while SGLT2 inhibitors reached unity. For heart failure, You would expect the SGLT2 inhibitors alone doing well, but in combination with the DPP4 and TZD, they cross unity. On the other hand, the GLP-1 RA and SGLT2 inhibitor combination just reached unity. So non-inferior, but not necessarily outstanding results. But what you will see is the all-cause death. The all-cause death, you will find that the GLP-1 RA significantly pushes the curve to the left. The GLP-1 RA SGLT2 inhibitor, you will find 0.78 with an upper limit of confidence interval of 0.82, and even with combination with the others, sounds very good. So clearly, what we know is that the SGLT2 inhibitor demonstrates a beneficial effect in reducing albuminuria. It attenuates the eGFR decline. In CKD, SGLT2s are recommended therapies to slow CKD progression, while the residual risk of kidney function remains. When you combine with GLP-1 RA, when there's persistent albuminuria, uncontrolled metabolic risk, it helps you. Dual therapy may be warranted to address residual risk and achieve comprehensive renal metabolic benefits. Remember that there is also finerenone that is available. It will be important to sort of understand which comes first, GLP-1 RA or a finerenone, but this is something for much more studies. GLP-1 RAs and SGLT2 inhibitors reduce the risk of MACE. GLP-1 RAs have a greater impact on reducing risk of non-fatal stroke when compared to SGLT2 inhibitors. Combination therapy is recommended for patients who establish ASCVD or multiple risk factors for ASCVD. Dual therapy aims to optimize CV outcomes and glycemic control in patients with type 2 diabetes. Therefore, the GLP-1 RA plus SGLT2 combination is particularly relevant for patients with suboptimal A1C levels and residual cardiovascular risk despite initial treatment with one of these agents. So what seems to happen? There's a disease of pipes and pumps. In the pumps, the SGLT2 inhibitors are superior. In the pipes, there's a lot of data on GLP-1 RA, and when they both work together, they seem to provide a lot of benefits in both of these. So GLP-1 RAs decrease inflammation, decrease smooth muscle proliferation, decrease platelet aggregation, increase blood flow, increase plaque stability, increase vasodilation, improve endothelial function. They improve natriuresis and diuresis. So here is question number 2. What are the possible direct mechanisms by which GLP-1 RA improves renal function? You can choose one or you can choose more. Right? A, inhibition of the sodium hydrogen exchanger of the renal proximal tubule. B, inhibition of renin-angiotensin system. C, decreased glomerular atherosclerosis. D, reduce renal oxidative stress. Your time starts now, and let's see what the answers are. 1. So this is what happens. There are direct and there are indirect effects. The direct effects include proximal tubular natriuresis stimulation and modifies cyclic AMPA-PKA signaling, inhibits the renin-angiotensin system, reduces glomerular atherosclerosis, renal endothelial dependent vasodilation, and increased tubular glomerular feedback. On the other hand, it also, by improved glycemic control, blood pressure, weight loss, increased insulin sensitivity and postprandial glucagon, increased intestinal lipid uptake, and increasing brown adipose tissue activation, and maybe effects on microbiota. There are indirect effects. It combats reduction in GFR by working at the sodium efflux, increasing tubular glomerular feedback, and vasoconstriction of the afferent arteriole. It also works on plasma renin activity, on natriuresis and renal oxidative stress, and works on albuminuria. So the correct answer is all 4, and mechanisms are in play here. So to summarize, dual therapy with GLP-1 RA and SGLT2 inhibitors provides greater risk reduction for ESRD and eGFR decline compared to other therapies. It demonstrates favorable effects on heart failure compared to other dual therapies. GLP-1 RA and SGLT2 dual therapies show benefits in terms of reducing MACE. The same dual therapy also exhibits a positive impact on reducing all-cause death when compared to the reference treatment. I will stop here. Thank you for your patient listening. I hope this was useful to all of you. Thank you very much.
Thank you, sir. Thank you for the wonderful session on oral semaglutide's real world evidence, showing us this data correlates with the clinical trial data as well and gives us the meaningful weight loss as well as glycemic control. And also taking us through the importance of dual therapy of SGLT2 as well as GLP-1 RAs and how it complements each other in reducing the residual risk for long term complications of renal outcomes as well as cardiovascular outcomes. Thank you, sir. With this, we'll move on to our next session by Dr. Vagish Iyer. Yeah. Dr. Vagish Iyer is the professor and former head, Department of Endocrinology, St. John's Medical College and Hospital, Bangalore. He is the president of Karnataka Endocrine Society. He is the former treasurer of Endocrine Society of India and former secretary of RSSDI Karnataka State Chapter. He has publications, poster or presentations of more than 100 in number in national and international journals, and he has been also contributed to chapters in textbooks, and he has also done oration awards like Sunil Das oration in 2016 and presidential oration in 2018, and he's been a principal investigator or co-investigator in more than 80 multicentric clinical trials. With this, we'll move on to the next topic by Dr. Vagish Iyer. Over to you, sir.
Yeah, thank you. Thank you very much for the kind invitation. Thank you, Dr. Shashank Joshi, for inviting me. Next 15 or 20 minutes, I'll take you through a journey of insulin, dichotomy between innovation and the adoption. Is my screen visible?
Yes, sir.
Is it visible now? Okay.
Yes.
Yeah. Thank you. I think insulin is one of the greatest discoveries the world has seen. I think probably this is the only drug which has survived more than 100 years without much problem. So this is a no sponsored session. I'll be speaking on behalf of the topics, but it doesn't make any difference to the science I'll be delivering. This is the agenda of my topic. So initially we'll be speaking why there is, in spite of 100 years of a discovery of insulin, why there is delay in initiating the insulin in throughout the world, more so in our part of the world. What are the hurdles, what we face, and what are the solutions for it, and evolution of insulin in the past 1 century. Then we'll conclude the topic. Diabetes prevalence is increasing worldwide, more so in the Southeast Asia and also Asia Pacific region. I think more than 2/3 or 3/4 of the diabetic reside in Southeast Asia and the Asia Pacific region, and it is going to be increasing. Whatever number projected here, whether 90 million by 2021 and 152 million by 2045, they are all conservative numbers. Means this we have seen in the past and we are going to see in the future also. This is the minimum number we are going to reach by 2045. That has been seen in the past. That's why we need to be careful when it comes to the advocating therapy and advice to our patients. But burden of diabetes is quite huge. This is one of the most recent study from Chennai from V. Mohan's group. 11% of the India's population is the diabetic, while close to 15% have in the pre-diabetic or impaired glucose tolerance state, suggesting that 1 in 4 people have a glucose not in the normal range. And the estimations are much higher than what has been reported earlier, whether it was from the PODI study from the 2003 or a much earlier one. The reason being, in a decade or two, the lifestyle has changed so much, the number is increasing, and we have beaten whatever the predicted number which was shown in 2004. Then comes, we know that insulin is one of the definitive therapy which is available over a period of more than 100 years, but initiating insulin in India is quite low. Nearly 1/3 of the patients are given when more than 1/3 of the patients only given when 100 people require insulin, and 46%, close to 50% of the patients are uncontrolled on glycemic parameters when we initiate a insulin therapy, suggesting our insulinization is quite delayed, and also the persons we initiate insulin, they remain uncontrolled. Then we'll come to a case capsule. This is about a 55-year-old. It's a common garden type 2 diabetic patients, what we see in day-to-day practice. 55-year-old type 2 diabetic patients, 8 years of a duration. His fasting is not under control, that's a 190. Postprandial is around 246. HbA1c is 9%. Suggestive, it is not under control. His creatinine is 1.2 with the eGFR of 92.9. Fairly good for most therapies what we want to initiate. His LDL is 90, quite optimal. He is on the standard of a therapy, metformin 2 grams per day, that's a 1 gram twice daily, sitagliptin 100 milligrams once daily, and empagliflozin 25 milligrams daily. I think this is quite a standard of a therapy wherever we expect. His glycemia is not under control, fasting is high, postprandial is close to 50 milligram above the fasting, and the HbA1c is 2% more than what we desire. I think 2.5% above what we desire to control him. We know that this is a quite common scenario, what we see in our day-to-day practice. I'm sure it is true with all of you, what we do. The question comes, what to do next? What is the best medication we can give him? Because he's already on a 3 OADs. Is it we should add a 4th OAD, or should we move to a insulin injection? What has been seen is whenever we add any OADs to the subsequent oral antihyperglycemic agent, the benefit of glycemic reduction is very, very minimal, because beta cells are already highly stimulated. By adding a subsequent OAD, we are not achieving much. So if 2 OADs are there, the subsequent addition doesn't benefit. That's why what has been seen is initiating or adding insulin is always a right approach and helps in bringing down the HbA1c much, much more better than what is seen with the adding a 4th OAD. The reason being we should control the glycemia well, because uncontrolled glycemia results in both increase in the microvascular and a macrovascular complication. Microvascular complication like a diabetic retinopathy, we know that diabetic retinopathy is a leading cause of a blindness in the working class group. We say that anywhere between 20 to 79 years is the working class, and diabetes is a leading cause of a blindness. Still, across the thing, cataract is the commonest, but in a working class, diabetic retinopathy is a leading cause of a blindness. Diabetic neuropathy is a leading cause for a non-traumatic lower limb amputation. Still, trauma is a leading cause of amputation, but the place where there is no trauma, if you remove the trauma from the list, non-traumatic amputation, diabetes is going to be diabetes is a leading cause of a lower limb amputation. People with diabetes are at the increased risk, 3 to 5 times at the increased risk of a cardiovascular disease, which includes angina, which may be atypical, coronary artery disease, MI, stroke, peripheral vascular disease, and also in heart failure, which is getting recognized more and more nowadays because we have got agents to tackle it effectively. And also, diabetic nephropathy is a leading cause for end-stage renal disease requiring a renal transplant thing. So that is a burden of the not only diabetes complication what we have got to face. That's why controlling glycemia appropriately with the other risk factors is a very much essential to prevent this micro and macrovascular complication. We know that insulin is a right treatment when somebody is taking a 3 OADs, but still most of the time the patient, like what we have got 55-year-old gentleman, patient refuses to accept the insulin. This is true across the globe, true to the great extent across India also. Let us analyze why this refusal. The barriers to initiate insulin many a times related to the physicians, even many a times related to the patients also. We'll concentrate one by one. Whenever you want to initiate the insulin, we need to educate the patient, and also to start the insulin, to educate the patient about the dosing, how to take, how to monitor, how to anticipate hypoglycemia, how to adjust the dosage. It takes lots of time. And we know that in a busy OPD in India, which where the doctors will be catering to the much more than the numbers they are supposedly to cater, you can see that the time given is very, very less. That's why this is one of the reasons from the doctor's side also to delay the initiation of the insulin. Second is, if you have got a diabetic nurse or a paramedical staff or an educated diabetic nurse, Many a times this insulin initiation can be taken care by them, but there's a lack of a manpower in this regard, counseling the patient regarding need of insulin, how to start, where to take, how to monitor. All these things can be very well tackled by a diabetic nerve. There is a lack of diabetic nerve in most places. That is the reason it gets delayed. One more thing is, whenever we initiate insulin, the anticipation is an hypoglycemia. We know that all patients with type 2 diabetes are prone for a hypoglycemia, more so when they are on a insulin. This is also one of the greatest barrier to initiate, because you may get a call from the patient in the middle of the night or anytime when you are outside or you're in a busy seminar. That is also one of the reasons there is a delay in initiating. Weight gain is one of the expected thing with the insulin. Hence, there is a delay in initiation of the insulin happens. More so, insulin initiation is a quite complex, and every patient's insulin need is a different. That also adds to the quality of life to the patient. That may also make physician to defer the insulin initiation. That's why one more thing is the training in insulin initiation is not uniform across India. The suboptimal knowledge on the guidelines, which insulin to start when, how to titrate, when to give, how to monitor, all these things are quite complex. That itself may put off the initiation. There are different guidelines, different recommendations from various organizations and the bodies. Targets gets changing, and for a physician, diabetes is not the only disease they need to see. They need to see most all the disease of the patient. That also makes them difficult to keep on the update. And the newer therapies and the knowledge available about the newer therapies is also less, because many a time the doctor may not get time to update himself. So to reduce this burden, better to employ nurses or a pharmacist or a diabetic educators who knows the technique of insulin, how to initiate, how to monitor, where to take, when to anticipate, what to do when patient has got a sickness, and all those things can be educated by the diabetic educators or a pharmacist and nurse who are trained in diabetes, so that doctor gets or a physician gets more time to deal with the complications and the management. More frequent review happens regarding the diabetes, and also it increases the trust and builds the strong foundation with the patient, and also it reduces the non-compliance. Compliance is one of the greatest issue with the chronic diseases. That is true even with the diabetes. With the newer therapies, we have seen that the chances of hypoglycemia is quite less compared to the older therapies. Weight gain is less. Even a quality of a life is good, because the stringent adherence to time, those things are much, much different than what it was earlier. Educating and training is a very important training. Even the doctors with the CMEs, hands-on workshop, how to initiate, how to titrate, how to intensify. All these things will help in identifying the right patient on insulin therapy, how safely we can administer the insulin, and also it involves, these meetings involves teaching the healthcare professional the right technique, and also how they can convey it to the patients. These are mainly about the barriers which are related to the physicians, but there are many more barriers which are related to the patient. Most important is psychological insulin resistance. It is not the actual insulin resistance what we are dealing with type 2 diabetes. It is a psychological insulin resistance. From inside, patient doesn't want to take insulin. That's the insulin resistance. Meaning that the moment the insulin has been started, patient thinks that he has reached the dead end of the disease, or he has reached the very serious part of the illness. Most of the time, they related the insulin therapy with lots of complications. Poor self-efficacy concerning the skills. He thinks that probably he may not be able to cope up with how to take the insulin, where to take the insulin, how to adjust the therapies. Fear of injections is the most important, and also there is a lack of correct or an accurate information regarding the insulin. most of the time I have seen my patients telling that they relate insulin therapy with a renal failure, heart failure, or certain surgeries and all. This leads to lots of psychological insulin resistance. That is also one of the delay for accepting the insulin initiation from the patient. There are lots of patient-related barrier when it comes to this psychological stress. It may be related to the injection, because anything painful process is quite anxious. They think that the control is not there. That's why doctor is giving the insulin. Self-efficacy comes down because he has to depend on others if he doesn't learn the technique. He feels that he has failed in managing his diabetes, and he thinks that with the insulin therapy, probably he's not going to get control of his diabetes. He is very much worried about the adverse effect, especially the hypoglycemia, weight gain, and also insulin therapy adds to the cost, because insulin is, he has to buy an insulin, he needs to monitor, those things adds to the cost. That also has an impact on the patient's stress. So, this is one of the studies wherein in excess of 3,000 insulin-naive adults with type 2 diabetes were recommended insulin. Mean time to initiate insulin in them was 790 days. That's more than 2 years. I think close to 2 years. 374 people initially declined. When it was advised to initiate insulin, they declined. Eventually accepted. It's just around 374 people. People declined but never started is quite huge, and people who accepted therapy without ever declining was 2,300. I think that this number is growing compared to what it was earlier, but still there is a big chunk of the people who refuse. Some people never initiate. So what is the impact of this psychological stress? Or psychological stress is mainly that there is a reluctance to accept insulin initiation. They reluctantly take, even if they take, they may not intensify, they stick to only one dosage that may not serve the purpose, because initiating insulin is only half job done. If you don't intensify, you have failed in your goal. This also leads to the prolonged period of a poor glycemic control. We know that poor glycemic control, especially glycemic burden, leads to the micro and the macrovascular complications. So that's why we need to overcome the psychological insulin barrier. Whenever we prescribe insulin, assess the patient, what is his knowledge, what is his prioritization about the control of the diabetes, what about his awareness about the insulin, benefits of insulin therapy and benefits of a good glycemic control. Is there any cost barrier? Is there any socio-economic barrier to accept the thing? Is there any psychological barrier suggesting that is there perceived inadequacy of whatever OAD is taking? What is the side effects? He believes that with the insulin comes. Is there any phobia for the injections? And also any other additional psychiatric thing is there we need to assess. So if we effectively convince the patient with the conversation, we can collaboratively initiate the insulin. So you can ascertain, we can explain and educate the patient. Whatever the problems he can facing, we can solve it. We can together, we can initiate the insulin, can have a plan how, what dosage to start with, when to titrate, and also we can give a realistic goals. In a 1 month, okay, we want his sugar to come down this month. We will intensify only if he accepts it initial 1 month. Those things can also be done. But one of the most important thing is lipohypertrophy. These are the fatty bumps or lumps, or the place where patient is taking. Most commonly, it is because of the repeated insulin taken in the same place. That is one of the reason. Second is even a less change of the needles. We have seen the patient taking the same needle for a long period. If he's taking using the same needle for a long time, also you will see this lipohypertrophy. These are the places where the pain is less. Patient prefers to take the insulin again and again in the same place, but the insulin absorption is less or an erratic, leads to the uncontrolled glycemia. We may fail in our option of controlling good glycemia. So where we have reached, I think more than 100 years of a discovery of insulin has happened. I think centenary celebrations were done nearly 2 years back. I think this is because of the fantastic work of the mainly two researchers supported by other two researchers. This is Banting and Best, Collip and MacLeod. All of them worked hard towards this, and they got a Nobel award, which was shared among the four. The initial insulin was quite crude. It was an animal preparation. I think if you remember, now we have got an insulin of 100, 200, 500 IU per ml, but the initial one was 5 unit per ml. You can imagine the amount of dosage patient has to take compared to what we are giving now. And once the insulin isolated in American continent, it was from the Toronto. Subsequently in Europe, it was started in Denmark from the Novo group. Initially, it was an animal preparation. Then intermediate acting NPH insulin was discovered. Then we got a human insulins. Then we got a insulin analogs. Then we have got a second generation and the third generation insulin analogs. That's the basal insulin. That's the insulin glargine U300 and digludac. But most important is with the newer insulins, we have seen lesser variability and a longer half-life, especially with the basal insulins. Basal insulins once daily with lesser variability are the need of the hour. Those things have been met with the new ultra long-acting basal insulin analogs. That's a digludac and a glargine U300. So what has been proven consistently with the insulin digludac is hypoglycemia benefit is very well proven. The lower rates of a hypoglycemic versus whether it's a glargine U100 or a U300. Glycemic variability is significantly less, whether it's an intraday, that's a within the day, or interday, in between the days, in comparison to the glargine U100 or a 300. And the most important, what it offers is a flexibility. So the flexibility of a glargine U300 is about 3 hours. So if you prescribe something around 10 p.m. he has to take, he can take anywhere between 9 to 12. But with glargine U100, there is not much of a flexibility. He needs to take around same time every day. But this is not the case with the insulin digludac. The flexibility is between 8 to 40 hours. If he forgets to take, he forgets to take in the night because of his commitment or because of some other job, he can take the same dosage next day morning without much alteration in the glycemia. I think that's one of the greatest convenience which has brought with the glycemic. This adds to the patient's flexibility and also his acceptance. Even a premix have gone through lots of revolution in the last 100 years. As we know that in 1921, insulin was isolated. Then came a monocompetent. There's a purer form of the animal insulins in the 70s. In the 80s, we got a recombinant human insulin. Then the analog mix in between 95 to 2000. Then we were analog mix with this is not a mix, it's a co-formulations. Co-formulation with the digludac and the aspart is much more different than premix insulin, what we are speaking. It's a clear solution where there is an long-acting and a short-acting mixed in the proportion of a 30% and a 70%. That is co-formulation digludac and aspart Rhizodec. So what is this Rhizodec or IDEC aspart has got? It's a unique research co-formulation. Lower hypoglycemias. There is a flexibility with the meal time, quite simple regime, convenience of a device, one of the best of the device, improved quality of life, and a quite cost effective, and it's quite efficacious. It has been very well studied. Even people who were taking 4-time basal bolus in type 2, when were shifted with this co-formulation of IDEC as the control was as good as basal bolus with the 4 pricks with 2 pricks of IDEC asp. Even the delivery devices have gone through lots of innovation and improvement. From the crude syringe of 1921s, we have got now quite advanced devices. We have got the insulin pumps, insulin pens have gone through lots of modifications and lots of precision in delivering the doses. There are artificial pancreas has been introduced in 2015. Bionic pancreas has been in 2017. I think insulin pump, it's quite almost a size of a pager, what we used to use nearly 2 decades, is made available. I think this discovery of a devices made the insulin delivery quite efficient, and also acceptability has improved because of these devices. So still the patient and physicians identify higher frequency of insulin injection as a burden, because they feel that if you don't take injection every day, probably it's much more better. Good control can be done without everyday injection. It has been seen that missing of the doses is quite common. Omitting the doses is quite common. Non-adherence is an issue. Even in the clinical trials, we have seen that. We have seen even in the real world practice. To come to the conclusions, poorly controlled diabetes leads to increased risk of developing both micro and macrovascular complication in patients with type 2 diabetes. Despite advancement in the newer analog insulin with better efficacy, safety, convenience, and also newer devices, the adoption is quite low, refusal both from the physician part and also a patient part. Frequent insulin injections are quite burdensome, inconvenient, contribute to the therapeutic inertia and also poor treatment adherence. People with diabetes and the physicians prefer fewer injections to reach a glycemic goals. They want with the 1, maximum 2, but basal bolus, the acceptance is very, very less in patients with type 2 diabetes. I think this is my last slide. Thank you for patient hearing, but we have got a much more important insulin regimes to reduce this burden. Future is quite bright. There are newer insulins with the once weekly physiologically distributed insulin. Oral insulins are in pipeline. Glucose sensitive insulin release with which prevents hypoglycemias, and probably beta cell replacement is the real thing which can come out for our patients with diabetes. Thank you for your patient hearing.
Excellent talk, Dr. Iyer, sir. A very in detail you have mentioned about the insulin, why it is required, how we can delay the complications, and also how the newer insulins are helping our patients achieve the good glycemic control. We are now moving forward towards the panel discussion. I would request all the faculties who have joined here to turn on their videos. We have so many questions coming up from the audiences. I would again request all the panelists to start their videos also.
So we can start the panel with Dr. Vagish Iyer, sir, in the meanwhile.
Yes, sir, we have a couple of questions for you, sir. Some patients, they deny insulin by all means. Otherwise, they will change the doctors and they will go to multiple doctors. So please give some practical tips for convincing such kind of patient for insulin initiation. A very, very practical question we all face in our clinical OPD, sir.
Yeah, that's true. What matters is a consistency. For example, I have told that this patient requires insulin based on his glycemic values, his complications, or any other thing. When he visits the next physician, if a science and the guidelines are same followed everywhere, by and large, even that doctor tells that he requires, definitely the acceptance rate is on the higher. But by and large, what happened, I think one of the complexities is certain guidelines differ, certain targets differ. Fine. That is the one which leads to the confusion. And also, most of the time, what I tell the patient is, if somebody is there waiting area, he's taking a insulin, introduce that patient to person. He will tell that what was his life before initiating insulin and after. The quality of a life is always good with the insulin initiation. He wants to hear from the patient also, not only from the doctor. That is one. And also the seniority matters here. If a senior doctor tells, probably the acceptance is much more higher than the person who has begun. Not to disrespect any doctor or anything, but this is the fact when it comes to the patients, fine, in the practice. And what I tell my patients is, this is the only drug which is there for 100 years. Something is there for 100 years has to be good, because the perception about the insulin is a bad, because you have to get something is there for 100 years has to get, otherwise it can't sustain for 100 years. That's the one thing I tell. And also second thing, if you look into the Nobel awards the insulin has got, only I have mentioned the 4. We have not mentioned for the Sanger's award for the sequencing, and we have not mentioned the even the immunoassay, insulin immunoassay from the radio immunoassay what has discovered. I think there are close to 7 insulin awards given to the insulin and the insulin related things. That itself speaks about the importance of this molecule. I tell that is the only molecule in the history which has received 7 Nobels. None of it has received, and nobody is fooled to give 7 Nobels to the such a good molecule. So it has to be good. Most of the time they get convinced, not even in the first subsequent visit, but most important what I feel that we should convince that the patient natural history of the type 2 diabetes. He tells that 5 years back, I was not taking any tablet, my sugar was under control. Now I am taking so many tablets. Why it is? I told it's neither the fault of yours, nor the fault of the medicine, not the fault of the doctor. It's the nature of the disease. As the years progress, you do require addition of a medicine, and insulin is one of the definitive therapies for a type 2 diabetes. You have reached a stage where you need to take a insulin for a better control.
Perfect, perfectly said. The last point is, again, I feel very crucial to take out the guilt from the patient side, that he is not eating properly, he is not doing exercise. So it is not your fault. I think it will be a very good sentence for the patients. Again, a question has come yes, sir. Practically, how much difference in the hypoglycemia rate have you seen with human insulin versus analogs and versus the second generation basal insulins?
Huge difference. Definitely with the newer basal analogs, the hypoglycemia events are very less. And this has been seen when we are part of the clinical trials with the newer basal analogs, and we are seen even in the practice. Definitely it makes, especially with the comorbidities, it makes much more easier to use analogs compared to the conventional insulin.
So I also wanted to ask in relation to this question. So starting insulin for the first time, do you take this hypoglycemia into consideration? Either start with a simple insulin or start directly with the second generation basal insulin, because initial hypoglycemia is again a big concern.
No, I think the barrier for initiating the newer basal insulin is a cost. If cost is not a barrier for a patient, I think this is an ideal thing to start. And always when we start the insulin, for all I think listening, never aim at controlling with the first insulin dose you are giving. The first insulin initiation is only for acceptance. I think we are starting much less than what is required. If requirement is around 15, start with 10 or 12. Let patient come back. Then you up titrate and intensify, so that if patient experiences hypoglycemia on the first insulin dosage, he is never going to continue or never going to pursue with the insulin. That's why the first aim of an insulin initiation is mainly acceptance and insulinization of the patient. You call him after 2 weeks or 4 weeks. Subsequently, you teach him the how to titrate, how to increase the dosage, when to anticipate a hypoglycemia. So at one teaching session, we can't teach everything. At least it takes 1 to 3 months, different sessions. At each session, I think you educate regarding one aspect of the insulin, then the acceptance becomes better.
Thank you, sir. Thank you. We have Dr. Krishna Sesadri sir also joined. Thank you, sir, for coming for the panel discussion. And we have Dr. Shashank Joshi sir here. Welcome, sir, again. We have so many questions coming up. There is a question for Dr. Krishna, sir. Sir has mentioned duo of cardioprotective drug, GLP-1 and SGLT2 inhibitors. But many of the CKD patients with diabetes are already lean and thin. So can we give reduced dose of both drugs to give benefits in minimizing weight loss for both agents?
Right. So the thing is that there is not in patients with CKD and with this thing, remember the weight loss is a percentage one. Second, the weight loss is mostly fat and not muscle. So this is something that has been fairly well established with both these drugs. This is true. Third, the protective effects of these drugs are much, much more than the perceived effects of weight loss. Correct? So I have, and the fourth thing, for example, instead of the safety in terms of hypoglycemia are all much, much better than insulin itself. So most of us have no issues about starting these drugs the same. Even in and remember, even in non-CKD patients, patients who are who let's say have a BMI of 23, who do you start one of these drugs? What has been shown, and the retune study has shown, that weight loss even in these patients is actually desirable in terms of control of diabetes. So I'm very comfortable starting these drugs. If somebody here is frail, they're emaciated, they have muscle loss, they have other reasons and other causes, then I think we should investigate them before we starting these drugs. That is a caveat.
And I also think that the role of medical nutrition therapy in this kind of patients become very, very crucial, along with getting good muscle mass also. Thank you, sir. Sir, I also want to ask you about the question I asked Dr. Iyer, sir, from the audience, that some patients, they are very reluctant to start insulin, and they will ultimately change the doctors if you prescribe them insulin forcefully. So what is your practical points? Some of the audiences have asked your practical tips for convincing this kind of patients, sir. How do you, in your actual clinical OPD, sir, how do you convince them?
So I'm lucky in the sense that that most of them have come to me after seeing a few doctors, and then when I say you need insulin, they know, okay, this is the last resort. So there's nobody else who's going to tell me differently. So I'm lucky thereof. But I think I would look at this part of things. One, start the insulin conversation early in the course of diabetes. Right? Insulin is a promise and not a threat. I think that is one thing that I have been consistently saying everywhere. Second, and you can always go to insulin. It's not a bad drug. I don't do the Nobel bit, but I tell them, it is a drug that's been around for 100 years. It is the safest drug that we know. It is the best drug that we know. That's continuously something. Second is, I don't get upset when patients say no. Right? When a patient, I appreciate it, I understand it. Let me give you the reasons. Go home, think about it, come back. Let's take this conversation again. I will not refuse to treat them. I will give them an alternative. Even if and I will give my best shot in giving an alternative to show them, look, I'm trying my best, but at this point of time, you need insulin. So the whole idea is that I am basically karmanyevadikaras, right? So I do my duty, and the patient is the master of his or her symphony in his life. My duty is to help him. My duty is not to convince him. My duty is to help him. I help him along the journey. I don't abandon him. I tell him, look, you change your mind, I'm ready there. It's okay, come back, let's talk about it. But the mantra that I use is refusal is refusal for that moment. It is not the end of the conversation.
Perfectly said, sir. Thank you so much. We have so many questions coming from GLP-1 to Dr. Farke sir also, but unfortunately, sir cannot join. There is a question with Rybelsus, with snack. There is a wide variation in clinical effects and side effects of Rybelsus in different patients with same dose. Some get good effects with 3 milligram and some don't lose weight even with 14 milligram. Is the variation absorption is the reason? What about the injectable semaglutide variation? Any of you can answer it.
You want me to take it?
Yes, sir.
Okay. So remember that GLP-1 RAs itself, there is a patient-to-patient variation. With any drug, there's a patient-to-patient variation, and GLP-1 RAs is very, very well known. And it is not. There's nothing that predicts this. When you see that a patient is not responding, just make sure that they're taking the medication correctly. Empty stomach, right? 30 minutes of no food or anything else, and 120 ml of water. This is something that we can all do. Also, make sure that, for example, you move to 7 milligrams, that they're not taking 2 tablets of 3 milligrams. Remember, the snack dose that is present in the drug is when you increase the dose, the absorption comes down. So these are small things you want to look at it. But remember that that there will be some patients whose glucose will get better, their weight will not come down. Some whose glucose and their weight will come down, and there's some who will not respond as well. That is well known in GLP-1 RAs. That is something that we have to do. Injectable. So when you take a GLP-1 RA orally, if the absorption is fine, then from then on it is indistinguishable from the injectable. So that's what we have.
Thank you, sir. Yes, sir, you want to add something?
That's all. No two type 2 diabetics are same. It's a heterogeneous disease. In the same family, we are seeing that 2 persons because we are dealing with somebody who has got a different BMI, different insulin reserve, different GLP response. So many other things contribute to it. So one factor doesn't respond. Only constant factor in that both the patients is in ribolysis. Nothing else. There are so many other things variable. That's why you can't expect the same response in all patients.
Yeah, thank you, sir. There is a question. Is the alternate dose of 14 milligram Ribelsus works? I think the same thing. Have you tried, sir, in any of the patients?
Alternate dosing. I have not, but there is at least one publication that seems to say that alternate dosing is, and Novo, close your ears, but there is at least one publication that seems to say that alternate dosing seems to work.
Thank you, sir. Thank you. I think we have taken. So another question. I think the well will be the injectable semaglutide and tirzepatide available in India. So if someone has asked about availability of injectable drugs, I'm sure they are blown away by the percentage of weight loss, and they are asking that. Any idea, sir?
So they're going to be available. I think they're shooting for the end of next year.
End of next year. Too far. Again, we have Dr. Shashank Joshi, sir, with us. Sir, you want to have any point regarding the discussion going on? Anything?
No, I think it was overall a very good symposium, and I think we have learned a lot of pearls of wisdom. 2-3 things which we need to recognize. First is that the oral GLP-1 is a game changer, and I think with the I'm very excited about a 25 and 50 milligram data coming up very soon. So that's really going to be a big game changer which will come up. And of course, once a week, insulin also looks very exciting. And I'm getting into a lift. Jimit, I'll just join in a minute.
Sure, sir. Sure. Sir, any final remarks of this newer generation of insulins and GLP-1s from both of our faculty members? How the newer developments are coming, newer ADA development, what we have learned from Dr. Joshi, first topic, and how do you see in the last couple of years the newer changes are coming?
Krishna and Vagesh, any one last minute, 1 point?
Yeah, I think innovation in the insulin has made acceptance and the control of diabetes better nowadays.
So I'm just going to add one thing. Several things have come together. But that one is the direct and the retune and those studies talking about how weight loss is tremendously important as a primary therapy for diabetes, and the availability of drugs that are pushing the weight loss and A1C reductions to the 10-15% range. So this is a game changer, and I think the next decade is going to be of this, the primary therapy of diabetes being weight loss, and I think that's where this is going. Having a weekly injectable, I think Vagish has already talked about it. So this is what I would. The last one.
Thank you, sir. Dr. Joshi, sir.
So I think I think we've had a very good symposium. I congratulate Novo Nordisk for continuously innovating newer and newer medications in both insulin space as well as GLP-1 space. And truly, we are looking forward to these new innovations for it to be beneficial to the Indian population. And I think, in times to come, we will see remission of disease possible, probably with the agents like semaglutide and others. So I think it was a wonderful symposium, and I'm sure many people will have many more questions. We'll be happy to answer them. Just send them to 1MD site or sashank.sr@gmail.com. I'll be more than happy to answer it, or I can send it to all our faculty. I would like to thank particularly Krishna, Vagesh, and all of them. I would also like to thank from MD team, Anirudh Saparnekar and Dr. Jimit Vadgama from my team. And I want to thank Sumananti for the coordination. Thank you so much. Jimit, you can give your final and conclude the session.
Yeah. Thank you, sir. And I again, in the last, let me again thank all the faculties. We had a wonderful sessions. All the delegates also were joined and being interactive and asking questions. And also, I would like to thank Dr. Shashank Joshi, sir, also for shaping this event, and also the core part of the Novo Nordics team for making this event possible and giving us the wonderful molecules also and wonderful academics also. Thank you so much, everyone. And over to Dr. Sumati for the last words, and then we can close the session.
Thank you, Dr. Jimit. On behalf of Novo Nordisk, we would like to thank all our speakers of today's session, as well as Dr. Shashank Joshi sir, for organizing such a beautiful event, which is more informative and educative to all the doctors and delegates who have attended the session. And also, we would like to extend our thanks to all the delegates for active participation and having us given us an interactive session, which led more conversation rather than being a didactic lecture. So with this, I would like to conclude the session.